So again, it gets for some reason with Excel files, the key might not exactly work for you. I don't know why. There's some weird download issues that I couldn't really figure out with respect to Windows versus Mac. But if you go to the website and actually just download this monuments data set straight through and save it to somewhere on your disk, you should be able to import the data set like we showed yesterday with the drop-down menu. Again, as most of you, I imagine, work with data on a day-to-day basis, most of you are not going to use the drop-down menu after a few tries once you kind of get the handle on the syntax. But again, if you want to import a data set from Excel, so if you had either downloaded the monuments data set or had downloaded that zip folder of all the data, you should have it in there. Again, for the lab though, we wanted you to name this something other than monuments. Again, it's not bad. That's not a bad name. But for the most part, my recommendation is keep things short. Usually keep things one case. I separate my variables by underscores versus camel case. So for example, the difference between the two, what I mean by camel case is like the variable is 5 versus the variable. So the first one is separated by underscores. Some people use periods. There's reasons to do that and not to do that. This is what's referred to as camel case. So there's like humps in the middle, right, where the things go. So it kind of just depends on your preference. But yeah, periods are fine as well. There's just reasons for not doing that because of other languages. It's not consistent. Other languages use periods for different things. So pretty much that'll read in the Excel file straight through. And if we want to look at the help file for read Excel, I'm going to bring that up. So one of the arguments you should note, even though you can do it on the drop-down menu, sheet. So if you have multiple sheets, you can read in whatever sheet you want. You can either index it by the sheet number, which I don't recommend, or the sheet name, which I do recommend, because you can shift the sheets around in an Excel file, and the first one might not be the first one, a week later. So that would be how you would maybe, if you have multiple sheets or something like that, and you didn't want to export them all. So we showed 2 examples on how to write these out. So write mine is monuments.csv, and write using write underscore CSV. And the one thing in the key, the reason we did that is because I wanted to show you what the differences are. So let me just run this really quickly. Whatever directory I'm in, they're going to get thrown in there. I'll just have to delete them. So this won't run straight through because, so the write underscore CSV function is in the read R package. Write.csv is in just, it's loaded up when you load up R. But write underscore CSV, I have to actually load up the library package, or sorry, the read R package. So we will talk, all right, so now let me take a step back with respect to packages. Okay, day 1, we installed all of them, or at least we tried to install all of them on everyone's machines. And again, they're all loaded on your machine, so they're just copied to your hard drive. If you want to use those functions, you have to use library. So if you shut down R and shut down RStudio and load it back up, that doesn't mean those packages are loaded again. You have to load them at every time. And again, you should put them at the top of your script so that if things kind of go awry, you kind of know where if packages weren't loaded, you know where to kind of look. And lastly, there usually isn't a problem with respect to which order you load them in. In some specific cases there are, so you have to load them in specific orders, where if 2 packages really have a lot of functions of the same name, then that can cause some issues. But for the most part, some scripts you're loading in maybe 5 to 10 packages max. If you're loading in way more than that, I would say you're probably trying to do too much in that script usually. You're trying to do probably data manipulation, and data summarization and plotting and making results, which I mean, at least for me, that's not the way I modularize my scripts. They are broken down in a series of steps. Okay, so again, we could have written this out this way, and yesterday we touched on it, but I'm going to go over again how you can save these things in an R kind of friendly format. Okay, so I want to show you the output of those two CSVs. Okay, I'm going to load these up in my Excel. So again, exact same object was written out, one using .csv, one using _csv. And once we kind of get to that, we'll be able to show you. Okay. Put this to the right-hand side. This to the left-hand side. Okay. So same amount of data. This one does have. This should have all the data in there. But the main difference I want to just note is that let's see up here. Name. This first column starts with name. This first column starts with nothing, and it has 1 to the number of rows. So one of the defaults in write.csv is to assume that you care about the row names, right? The names of your rows. So it says, okay, by default, I'm going to print that out as a column. And there were reasons before why that existed, but for the most part, you don't keep real data, real relevant data in the names of your rows. You actually make that a column of your data set. And this is one of the big differences that we're going to touch on today between this object I call a data frame, which has been used for the last 15 and 20 years as like this is what we use to analyze data, versus these Tibble objects, which has come around about the last 5 to 6 years and have become more popular. One of the biggest difference between these two is that Tibbles, again, I hate that name, but Tibbles, they don't allow you to have any row names. So like I said before, there is a row names and a column names function, but in Tibbles, that row names function is more or less irrelevant because the idea is if it's relevant data, you should have it as a column. You should be able to access it like every other piece of information in your data set, right? It shouldn't give this special. It shouldn't be given this special or different accessor, right? So I don't think in Stata you can even have names on the rows of the things.
So in Stata you have you can have observation numbers, sort of along the left side. Is that equivalent to a row name, or what? Is there an equivalent to that in the Tibble? Because we do occasionally use that.
So what do you mean?
So if I have a database, from a DHS or something, each row will have like a number along the left side, and those can if you sort it, those rows aren't hard coded, right? So if you sort it, the row number.
So is it in the data?
It's not in the data. It's how Stata identifies, that the way that the data are sorted, right now, the 5th row has actually a number 5 next to it, and you can
So you use a little L if _n equals 5.
Yeah.
Yes. You can still do that.
Okay.
You can still subset based on the row. But that is not like an actual piece of information in the data.
Right.
You can still so you can still subset based on which row it is.
Yeah. Okay.
That's totally fine by index.
Yeah. Okay.
Totally fine. But I'm saying one of the data sets we have, for example, the way the data is structured is it's all the child mortality from the 1700s that existed up until now, plus some projections. And the first column are the countries. And if you write it in a certain way, the countries were row names, right? Because everything else about the data is numeric, except for that one row, or except for that one column. And so some people, for example, would keep it let's keep it as a matrix, which is a totally different object, which we'll talk about, because everything's numeric except for this one. So we're just going to keep the labels there. That's not the worst idea, but for example, that's why if you change that object into a tibble, those row names go away completely. And some of the test data that we're going to work with in R, they have row names to the data, right? And that's why we're going to work with them to show you kind of the difference between these two, because if you, for some reason, or if somebody gave you something where information was encoded in the row names, then that data is going to go away when you use these, like the functions I'm going to describe. That's the big message there. But the reason why we don't use kind of this old, I would say this, it's older, but this older object called a data frame is largely because a lot of the newer functions allow for more flexibility. So you can have, for example, a data set that's grouped by certain variables. And when you perform operations of summarization, like we're going to talk about today, like let's say you have, a patient over time, and you want to collapse that data into, let's say they each have 10 visits, and you're just going to want to get the mean blood pressure measurement over all 10 visits. You can group that data by patient, and when you do the summarization step, it knows that to do that by observation, or by patient, let's say. So the older way with data frames didn't allow that. But this is kind of like a network of things. So that's not what we're talking about here. This is like these two functions writing out. But the philosophy stays the same in the sense this is part of that new thinking that row names are not supposed to encode data. And so therefore the defaults in this don't write them out. Actually, I don't believe if you even tried to write out the row names, it would even let you. So that's another reason why we use write_CSV versus write.CSV. So again, if you're working with someone who's worked in R for a long time, or even not a long time that just hasn't adopted this different kind of, let's say, way of thinking, they might say, why are you using this code? We're depending on another package. Why are you doing this? And these are some of the reasons. Okay. So I'm gonna show you, and then we're gonna jump back to the slides. So the other way you can save something in R, or save a collection of objects, there are two functions. One, the save function, right? So you say save, you type in a list of arguments, or a list of objects. So let's say mon was one of them, and then you specify what the file should be. Monuments, data, and then you can make it an R data, capital R, capital D, or an RDA, all lowercase. So this is an R-friendly format. So I can save that. It saves to my disk. It's by default compressed in some capacity. And so if we look at that on disk, right? So we see monuments data. I can't make the Finder window bigger. So we have that here. And if we want to read that back in, so one of the things that I don't like about the save functions in R, they aren't necessarily consistent. So I would think. So the opposite of save in R is load. Okay, so you would say, we'll talk about what this command does. This command this seems a little weird. This is the equivalent of clear in R. Clear everything. Clear literally everything out of your environment. So it's a remove everything in your workspace. And I'll talk about the RM and the ls commands in a minute. But if I say load, monuments, data, right? Let's look in our environment. Now we see after I've loaded it, monuments is back in there. So let me run those two commands really quickly again. So that cleared out everything. I'm loading it back in. So loads in the things I saved. So if I save 10 things into that RDA, 10 things will show up when I load it. Now, that being said, mon is now just the number 5. When I load something, if you load something into memory, you already have something in memory defined as that. It's going to get overwritten. Okay? So I had mon defined as 5. I loaded something, with a data set called mon in there, mon is no longer 5. Okay? Usually, if you're going to load things, a lot of times you'll load them at the beginning of a script, right, where you haven't defined a bunch of things over and over again. So even if you're going to like merge things later down the line, if you have like 5 or 6 RDAs where it's like follow-up data, demographic data, that kind of stuff, you usually load them in the beginning. Okay. So I'm going to jump back to the slides because there's another way about saving data that we didn't really get to discuss, and this will maybe make clear what I was talking about was why I'm not the biggest fan of the naming conventions for loading. Let's see. All right, so this is at the very, very end of the data I/O lecture. So again, this is the way we said we could save things. All right, so these are 2 commands. These are really 2 commands that are relevant. So ls stands for list everything in your environment. So this is more the command line equivalent of looking at that environment pane. Right? That environment pane will show you everything that you have loaded in memory and kind of the structure of that kind of stuff. ls will just list them out. Say these are the objects you defined somewhere in your session. Okay? So, like I said, I don't always use all the panes of RStudio. I've been working on it a little bit longer, so the idea is I use this function a lot more than maybe looking at the environment pane. But it's not just useful only for that. It's useful because when we combine it with the rm function. The rm function says, remove something from my workspace. A lot of times you don't need to do this. It's not a big deal. You can just overwrite it. But let's say you've loaded in something really, really, really big. You said, I don't need that anymore. I want to free up some memory on my computer. You could say rm, and then you could say list equals, and then you put that object, the name of that object in quotes. So let's say I had x somewhere defined in memory, right? I said x is this huge, huge case, and I don't want that in memory anymore. And you say rm list equals x, and let's say I also want to get rid of that youth tobacco survey data set in my memory. This would be what I do, and now they're just simply removed. They're not overwritten, they're no longer defined, so if I wrote x at the command line prompt, it'll say, I don't know what you're talking about, we have no x. Okay? So, again, we list everything out, we remove these 2, if you list it again, those 2 are removed. And when you combine these 2, when you say rm list equals ls, like I just did, it just says clear everything out, delete everything. So ls says, what are all the things loaded in memory? Rm says, I'm going to remove some things, and when you combine the 2, you clear everything in memory. That is, I don't know if that's actually a convention, a thing a lot of R users do. I tend to do it for 2 reasons. One, I've worked with data for a long time, and that's just kind of the way you start to think about clearing everything all the time. And then the other reason is because sometimes I'm doing something interactive with a script, and sometimes you may reorder code in a way where things are still working when you're interacting, right? Because let's say at the top of the script you did all this stuff, and you made a data set, and you read a data set in, and all that kind of stuff, and maybe you forgot to put some of the stuff you're doing interactively into a script, and then you closed out, and you start back up, and things don't work. A lot of times that happens because you were doing something interactively, or you did something out of order. You put something in the wrong spot. Like, this data set doesn't exist. Oh, that's because I haven't read it in yet. But when you're working interactively, and you're just trying stuff out over and over again, usually I run everything from the top of the script, and at the top of my script I say remove list equals ls, and I say clear everything out, just like if I had restarted my R session. The biggest difference between clearing everything out of your memory and restarting R, the main difference between those 2 processes are that when you clear everything out, packages are still loaded. When you restart R, packages are no longer loaded. So let's say you're working on script 1, you loaded 5 packages, everything went fine, your script ran well. Then you're like, oh, let's work on script 2. You started working on it, everything went well. You close down R. You open up script 2 now, things don't work, it says, I don't know what this function is, all this kind of stuff, that's probably because in script 2, you didn't load in a relevant package. Right? But in script 1 you had, and when you were working interactively, it was already loaded. So those are some of the common, I think, hiccups when you're working on multiple scripts at the same time. Okay, now, I don't like this because when you say z equals load, at least with respect to all the functions we've used previously, right, that do read CSV, read whatever, read Excel, the thing on the left-hand side is the thing that was loaded, is the thing that was read, is the data set. That is not the way load works. So load is not a read function, right? So the difference between this and something, and we'll get to another way, the thing that is in Z now is the names of the things that were loaded in. So for example, in YTS data, there was X and YTS. We saved them out into an RDA, just like we saved mon out, right? So when you load up monuments.rda, mon gets loaded in memory. So if we said load monuments.rda and z is equal to that, z now is a character string with the word mon in it. So let me demonstrate. So load is a little bit strange, but you need to know how it works. Because because loading and saving is really, really relevant because a lot of times you don't want to just save one thing. You want to save a whole collection of things. Like you don't want to save, okay, this, I want to save one file for my data set, one file for my model, one file for that plot, like as objects, and I'll load them in somewhere else. Usually you want to save a collection of things and then load them all later, right? So what I'm saying is, when I ran this command, load took whatever was in the RDA and put it in my memory. Right, so let me delete this so I can demonstrate. All right. So I cleared everything out. So mon is loaded, and z now contains mon. So if I had 20 things in here, if I had 20 things in this RDA, z would be a character vector with 20 different names in it. Right? It would be a character of length 20. So the output of load says what got loaded, what got loaded up. This is kind of just the way it is, but it's not the same way you think about when you read in individual things. So there is a way. So again, it is the names of the objects, not the objects themselves. So there is a way to save one thing. You want to save one thing? So it's called an RDS. So you say save RDS, the object, and the file. The suffix, the ending is different. It's not an RDA, it's not an RData file, it's an RDS file. So this is if you want to, for example, save one data set out. Right? So this is my analytical data set or something like that, and I'll load that in later. And the next slide will tell you why I don't like this naming convention, because I believe this function should be called write RDS, because that's what it does. It technically saves it out, but it writes it out to disk. And the reason for that is because the function to read in an RDS is read RDS, not load RDS. So it's save and load, right? Save saves like a bunch of stuff. Load loads it all in the memory. Save RDS saves one thing. Read RDS loads that one thing. Okay? So they either should be save and load RDS or read and write RDS, but it is a mixture of the two, and so it's bad. Okay, the biggest difference though, because it knows you're only looking for one thing, when you say read RDS in the file name, whatever's on the left-hand side contains the object, contains the thing that was read in. So again, this is a data set. This is the Youth Tobacco Survey data set that we just saved out into an RDS file. When we say this, YTS2 equals this, YTS2 doesn't contain the name of anything. It actually contains a data set of the Youth Tobacco Survey. right? So this is more like read and write CSV, right? When you write a CSV to disk, you say write CSV, the data set, CSV file. And when you say read it in, you say, what do I want to call it? Equals read CSV file name. Save RDS and read RDS are similar in that way. Load and save are just like a weird offshoot of sorts. Okay. For the most part, though, there is no problem whatsoever with that, with writing out CSVs and that kind of stuff. The only problem with that is it's not easy to save certain objects in R to text type formats, like models and stuff like that. So you have to use some of the R data types in order to save them to disk. So either save or save RDS. I would recommend just using save as kind of a shotgun. You're just like, I have these 10 things I want to save them in. If you want to use them in another script later, load them in. It's totally fine. Okay? And the only thing is this function identical just returns true if things are exactly the same. So I just wanted to demonstrate that although we wrote an RDS to our disk and then we read it in, nothing has changed to the data whatsoever. Okay, so two data formats that are R-specific, RDS or RDA. Okay. RDS only contains one thing. RDAs can contain everything you've worked on in that entire session if you want. When R asks you when you close, do you want to save the workspace? Right? That's what it's asking. Do you want to take everything in that environment and pretty much say save on that? I would not, also, as an aside, I would not, that's not the way I would save the data. I would explicitly do that in code because that R data file, when you load it up, can be different depending on the directory you open. So let's say, again, you have two projects. You save the workspace in one, you save the workspace in another. They don't talk to each other. So if you open up project A, the workspace from project A will be open. If you work on project B, the workspace from project B will be open, and that's fine. But relying on that as to save your progress is not a recommended thing to do. So it's okay to save your workspace and be like, all right, I'll get to this tomorrow. But it's not like, oh, I have an analytical data set. Just load up my R and there it is. Especially if you're working with relatively large data. Right? That thing can get pretty big on your disk pretty quick. All right. Yeah.
Is that, when it says save workspace, is that exactly equivalent to save ls, whatever name you give it?
More or less, yes. There is save.image. If you look at the help for save. So yeah. So this is what it's actually calling. This is a shortcut for save ls. All, everything. Right?
And it saves it as an RDA.
Yep. And it'll save it as a file. It's usually, so the file is .rda. So depending on how your system's set up, usually files that start with a period are hidden. So if you open up that folder, you might not be able to see that. So for example, I open up my folders, I can see every single file. So I can see every single file that exists on my disk, even if they're hidden. But for example, even if you say, save my workspace, and you look in that folder, you might not be able to see it depending on the configuration because it's a hidden file. Right? And that's another reason you can change that. I mean, you can just use save or save.image and save it yourself. But another reason why they do that is because it's a good, helpful shortcut. It's a good way to kind of do a little bit of your workflow, but it's not necessarily it's not to be used as the way you save data as checkpoints. Okay. Saving, fun. Let's get into some data summarization and subsetting. But before I get into that, I will say, I've gotten a warning. Okay. Give me 1 second. I got a little, if I don't change this, the warnings. will be on every single slide. So the other thing I was going to suggest, once we get to maybe Wednesday, it might be helpful if you say, this is the thing I do, and if we don't cover today or tomorrow, you say, this is the thing I do 1,000,000 times a day in Stata or whatever you're working in, and I don't know how to do that in R, and if I don't know how to do this in R, I'm not even going to use R. That would be good to know, because then I can do that. Sorry, when I recompiled, it had a little warning in there. Okay. So we're going to talk about how to group data, summarize data, and just do some basic stuff like mean, standard deviation, that kind of stuff, because that's what you do in a lot of these studies. So if you know SQL, this is going to make a lot of sense. Like, these are the verbs of SQL. Like, you group stuff together, then you select columns, and you filter rows, and these are the way, and then you mutate columns. So you, in order to add or change things, that's the way it's kind of described. Give me 1 second. And then we're going to do a little bit differently. So yesterday, because there's no really labs until later, it's a lot of me talking, and then us doing a lab. This will be more of me talking, then lab, talking, then lab. Okay, all right, let's refresh this. All right, well, we're gonna get this warning up there. Just disregard it for the time being. I don't want to waste any more time on it. Okay, so don't worry about the thing at the top. So we showed one way to read data in R using the read_CSV. Now we actually want to do some data manipulation, data subsetting. So we're going to be talking about selecting elements by an index or a logical condition. So example, selecting on row 5 or selecting on people who have ages greater than 32 or something like that. So renaming columns, subsetting rows, subsetting columns, adding new columns to a data frame, ordering the columns, ordering the rows. Okay, so this is the first. This is the second package we're really going to delve into. The first one was read R. This one's called Dplyr. So there are a lot of really good vignettes online or tutorials online to get up and running with Dplyr. We're going to cover the majority of those cases today, but these are some really good resources. I would definitely check them out. They are very well written. But before we kind of get into working with data frames and that kind of stuff, I want to talk about subsetting in general. And so we're going to start again at the back with vectors. All right, so again, X is just 5 numbers. So the way you subset a vector is you use brackets, square brackets. So when I say X bracket 2, that means give me the second element of X. We get the number 4. Everything is indexed. The first element is 1, right? The first element is the 1th element, not the 0th element. Other languages, in order to get this number, you'd say X bracket 0. That's not how it works in R. Computer science people hate that, but that's not the way I see a little. Yeah, I mean.
Always forget that.
Yes. So everything starts with 1. Okay, but the way you do indexing is different between vectors and matrices, and even different between matrices and, for example, data frames. So okay, we want the second element, number 4. Let's say we don't just want one element, we want multiple elements, right? So you just pass in a vector of indices. So in this case, again, we're just showing you what X is. We can say X bracket 5, it'll be the 5th element, that's 10. But let's say we want the second and the 5th element, right? So you say X bracket, and then you put that vector of indices in there, right? So it's like, oh, I grab 2 and 5. Great. So negative indices remove things and return everything else. So X negative 2 says, give me all the elements except for the second one. Okay, drop the second one and give me everything else. I will say I don't use negative indices that much. Two things. I usually subset things based on some sort of logical condition. And It's just kind of the way I think. I believe this is kind of the thinking of keeping versus dropping, right? So usually when I'm selecting things, I make some sort of condition that keeps the things I want and everything else will be thrown out, versus saying these are the things I want to get rid of and I drop them with a negative index, right? So there's just two ways to do the same operation, but just the thinking is a little bit different, right? So I would probably do something where I get all the indices like 1 to 5. I'd say, C parentheses 1, comma, 3 to 5, rather than dropping this. All right, so one of the big reasons why I don't use negative indexing is because you have to be pretty careful with it. So we could either have done, so we can do this where we say x negative c 1 2 3, right? So this will drop the first 3 elements. So again, the negative indices will drop them. So what this will do, this negative out in front, it'll just do -1, -2, -3, kind of like we were doing before, right? It's just shorthand for -1 times that, -1 times the vector, right? Putting the negative out in front. We could have done c parentheses -1, comma, -2, comma, -3. Now, 2 more things. The colon operator. So when you look in your environment and you see something that had like 50 things in it, right? I'm going to show you. So when we said x is like 100 random normals, r norm 100, I'm just going to go to the environment, and it shows you in this way. So it says num, but it says 1 colon 100. The reason it says that is because there is a colon operator in R. And more or less what it's used for is to create sequences of numbers in steps of 1. So you say 1 colon 3. So it was 1, 2, 3. Right? 1 colon 100, 1 to 100 by 1. That's great, but sometimes if you're not careful, that shorthand might backfire a little bit, or might not give you what you want. So -1 colon 3, or is not going to give you -1, -2, -3. It's going to give you -1, 0, 1, 2, 3. Right? So you can't mix and match. You can't use negative indices and positive indices at the same time. R doesn't know what you're talking about. When you're using negative indices, you're saying drop this stuff out, keep everything else. And when you're using positive indices, it says just keep these things. Right? So if you're doing both of them at the same time, it says drop these 2 elements, keep everything else, but then only keep these 2. It just says make up your mind. Either keep these things or not. Okay? So if you did want to do, 1 to 3 and then negate it, you have to again use the order of operations. You encapsulate them in parentheses and then you do negative. Yeah.
So if you did that -1, 2, 3 thing, what would R do? I mean, what's -1, 0 in this case?
It's going to say that you can only mix, well, let's see. Zeros may only be mixed with negative subscripts. So that's because -1 to 3 gives us all these. So it says you can either have negatives and up to 0, right? Only those, or positive things. You can't mix and match. But let's say we did, that's the error you're going to get. So it's saying you have positives and negatives in there. I don't know what you're trying to do. It doesn't make sense to me, by the way it's set up. It's funny because this class, like, they're great questions, and that's the questions I want to ask. But it's like all day in programming, you're striving to do like nothing remotely like this. So like your goal is to like do everything you can to like knock it in this realm, and then to teach you want to see like what happens if I do this, what happens if I do that, and it's just like I don't know. I really try never to do that, but yeah. So a lot of times, although you might be subsetting on base index, right? Like let's say we were saying before, I want the 5th row. Most of the time, you're subsetting based on a variable or a column or some sort of condition. So so we've talked about characters, we've talked about numerics, we've talked briefly about factors and categorical variables, but we'll talk about them more in depth. The third data type we're going to talk about today is logicals. Okay, so x is 1, 2, 4, 8, 10. So when you say x greater than 2, it'll give you an index true or false. Right? True, the condition is true, false when it's not. And again, these don't have quotes around them. So you know that they're not characters, they're not numbers, so they're this third class logicals. Okay? So now, but before we were putting a vector of indices, or a vector of indices in there, yeah, to say I want the second and fifth element, right? Now we can put a vector of logicals in there, and wherever that logical value is true, it'll return those. So in this, it says x greater than 2. These two cases, 8 and 10, are true. So it says x bracket, where is this true? When it's 4, 8, and 10. Those three cases. So we're just filtering, right? So now we've used bracket notation, but we've subset based on indices, and then we've also subset based on a logical. Most of the time when you're doing data, actual data, this is what you're doing. You're filtering based on some condition, right? Whether an ID equals 5 or within this set or something like that. Okay, so we have comparison operators like less than, greater than or equal to, all that kind of stuff. We have logical operators that can combine two logical statements. So the AND operator is the ampersand. The OR operator is called the pipe, or just the OR operator. It should be above your enter button. It is a straight line. Okay? So this is saying, where is x greater than 2 and less than 5? And I want to get the actual value from that, so I'm subsetting. And the only value where that works is 4. And if I say, is x greater than 5, or is it equal to 2? So again, the logical operator for saying is something equal to something is not just one equal sign, it's two equal signs. The not equal sign is the exclamation point equals. Right? So x not equal to 2 is x. I call it the bang equals. Right? So it's the exclamation point. Yeah, I don't know why I call it the bang. It's called the bang. I don't know why it is though. In some places, exclamation point equals is not equal to. So tilde equals 2 does not work. Right. So if you use that, you got to break that. Right. So exclamation point equals also works in Stata. I believe it works in SAS. Tilde equals 2 does not work in ARM. Okay. So this is saying, where that's the case, this is it. Is it greater than 5 or 2? So it gives these 2 because they're greater than 5, and it also gives 2 back. We'll talk about what happens with missing data there. Different stuff happens. So if you want to take a logical vector that says true, false, true, false, true, false, and you want to get the indices of where it's true, the function which is the function you're looking for. So we passed in this condition. X greater than 5 or x is equal to 2. Right, so that says true, false, true, false. It's true for 2, 8, and 10. Right? We say which around that. It says the indices where it's true. So it says the second element, the fourth element, and the fifth element. Okay? So this is a way from saying like which rows had this bad data or something like that. That's one way you can do that. And again, it gives you a vector of indices, so you can still pass this into the subsetting just all the same, right? So you can either explicitly make the vector yourself, not usually what you do. You can either use a logical condition, or you can use which. So the biggest difference between the logical and why you sometimes will use which, if there is missing data and you're not necessarily careful or explicit about that, a logical operation may or may not return missing. There are some cases where logicals can return trues or falses. There are some cases where it will return missing, right? Based on like some logic. So if you say like something or true, it doesn't matter what that something was, right? That condition is always going to be true, right? Like let's say you had someone with a missing age and they were male, and you wanted to subset people who were over 80 or they were male. Even though you have no information about that person's age, right? It doesn't matter. That condition is still true. They still who cares if they're over 80 or under 80? It doesn't matter. They're male. That condition would come out true. Whereas if you said, I want someone, they're over 80 and they're male, we can't determine that condition if they don't have an age, right? Because we need both pieces of information for that to be true. So that'll come out as missing, for example. It's very different than data. It's not infinity. So which will convert from logicals to indices. All right. So again, we're going to create a data frame to work with. So NT cars is a data set that's loaded up with R. It's when you download R, you get it in there. It's a data set that just has some car level information. And DF, we're just reassigning it to something a little bit simpler than NT cars. We're making a copy of it, and we're making a Tibble with this function as.tdf. DF. So really, looking at if you run these three commands and you look at the differences between the three, the biggest thing is the same point we've been hammering over and over again, is that Tibbles do not store row names. MT cars has the type of car that's relevant to this data set. So there's a bunch of different cars and characteristics like miles per gallon, number of cylinders, all that kind of stuff. If you look at MT cars, or if you look at DF and you look at Tibbles separately, DF, you know which car it is because it's in the row names. You can look at it. Tibble, that data is completely removed. All right, so number one thing you usually want to do with the data set, because people name variables in all sorts of different ways, and people think in very different ways, and if you're reading stuff from Excel, it does some lovely stuff with some spaces, and people just like to write variable names as like complete sentences. So first thing you want to do is rename things. So one way we showed a little bit briefly before, yesterday, is the column names command, or the names command, right? So here we're saying column names, right, of the data set, bracket, right? We're subsetting those column names, taking the first three, because we know how that, we've looked at the data, we know what those first three columns are, and we are just changing them to MPG, cycle, and disp, right? Before, if you look at the data set, they were all lowercase. So all we're doing is making those three uppercase. That's all we're doing here. So, but let's break down the command really quickly. Column names, we're accessing the column names, we're subsetting only the first three. And then, because it's on the left-hand side, and we're using equals to something on the right-hand side, we're reassigning them in that data set. Yes?
So instead of using the number of the column, if you know that it's lowercase, can you use the name of the column instead?
Yes. So we will get that in the next slide. That's a good question. This is, again, dangerous, not the way you usually do it.
Yeah.
So this column names is really good. So we'll show you another command that's a little bit more intuitive, a little bit more kind of state-alike. Column names is this methodology is still relevant, even though it's the base R way. If you want to do things like very wholesale. So let's say you want to make everything lowercase. This is the way you do it. You grab column names and then you say the column names of the data set are equal to the lowercase version of them, and you do that programmatically with the command toLower, right? So that's if you want to do something usually gross, and I mean that as a large scale. So again, we see that those are changed. I'm just changing these back because we're going to keep doing things like this over and over again, showing you the same command. So I'm just resetting those three columns to the original state. So, like the question you had before, we can use equals signs. Doesn't matter if they're numerics, doesn't matter if they're characters. We are now assigning Cn to be the column names of the data frame. And again, when you do assignment like this, those things are no longer bound in any way. Cn to R is just a character vector, right? It's just the column names. If you can delete Cn, you can make it the number 5. It doesn't matter. That's not going to change anything about that data set yet. Okay? So we said Cn is equal to column names df. And then we say Cn bracket Cn equals drat is equal to the uppercase. So we said take the column that was the lowercase drat and make it uppercase, right? So if we knew the column, that is, again, only assigning one. We want to assign them usually, not one at a time, but this is an example if you wanted to assign just that one. And now, again, nothing's been done in that data set. Nothing's been done. We've just changed a value in a character vector. In order to implement that change on the data frame, you have to reassign it. So now you're saying the column names is this changed vector. Does that make sense? Okay. Again, just removing that back. So this is doing it in more of an incremental approach. You assign it to something, you change that thing, you change it back, you assign it back. You can do it like this. We say column names, data frame equals to column names equals. That is just more of a, there's no problem with that code whatsoever. It's just a lot going on. That's all. Right? So you're grabbing the column names, you're checking a condition, you're subsetting based on that condition, then you're reassigning. So there's a lot of stuff going on. So I would start out step by step. So that's the way you do it with base, and that's one of the things I will still say that like you still should use. Column names is still a really good function because you want to do things usually at a large scale. Also, we're going to show you a little bit later how to do some string manipulations and stuff like that. So if you can get the column names as a string, as a character vector, you can do any of the string manipulations you want and then reassign them later. Right? So the big thing about this, right, as long as we don't reorder the columns or sort this vector in any way, they're still one-to-one. The first element of CN is the first column of the data frame, and so on. Okay. Okay. So on your machine, type library Dplyr. And you'll get a lovely message. You probably won't get this morning message, but you'll get something about masking. Yeah. So it looks really ominous and warning, but it's fine. So this is what I'm talking about. When you have two packages loaded that have a function of the same name, you will get something like this pop up. And what it's pretty much saying is the stats package has a function called filter. It's some function that does like temporal filtering and that kind of stuff. We're not going to use that. Doesn't matter. But it had a function called filter, and that was loaded in your memory. We loaded up Dplyr, which also has a filter function. Much more useful for what we're going to do. So it says, hey, you have two functions loaded. They both have, you have two packages loaded. They both have a function of the same name. I'm just letting you know, if you use one of them, you better know which one you're using. That's all. So when you type in a function, for example, if you just write filter now, you'll see something like this. Very not intuitive of what it does, but just write it out. And again, one of the things, so you're saying, oh, I loaded up 5 packages, like I think I'm using the right function, I don't really know. Like things keep going wrong, is it the function, is it something like that? This is not that common of a problem, but it is still a problem. So when you see this, at the bottom again, namespace colon, it's telling you that this function that you're going to call filter is from the Dplyr package. There are ways to be very explicit to say, I want to use the function from this package. We'll get to that. But again, if you forgot to load up Dplyr and you write filter, it's going to try to do some temporal filtering on your data or something like that. So just be aware that like it says, oh, the filter function works. The filter function exists. I don't know what's going on. My code's not working. That sometimes is why. All right. So just to show you, right, filter is this function where you put in some data and some other stuff. The stats filter function is this totally different thing. You pass in a vector, a filter, what kind of method of filtering you want to do. Do you want to do it on both sides, that kind of stuff? That's not what we want to do with our data. We just want to subset the rows. That's what filter is going to do. So if you look at this function, it does all these other things. And this is the way you can be, if you still wanted to use that stats filter function, even though you had loaded up Dplyr, the way you could do that is this syntax: package, : function name. So it's just saying, I want to use the filter function from the stats package. So if you ever see code like this, that's all it's doing, is being very explicit about which package it's using. And again, this isn't usually that big of an issue, but there are some things online that use this package called Plyr. Plyr came out. It was really good, did data manipulation. They said, well, it's not the best. And they wrote Dplyr, which I believe is a lot better. And they said, okay, great. The issue with it is, not everything was ported over. Some of the help online will show you how to do stuff in Plyr. And if you load Plyr and then Dplyr, they have a whole bunch of functions that overlap. So you'll see this huge like thing that says like all these things are masked. But if you happen to wanted to use some of those other functions, this would be the way you do it. But that's all that masking means. So it's not a warning, or it's just a message. It's not a warning. It's not saying you broke anything. Okay, now rename things the Dplyr way. Now I'm just being explicit. So Dplyr rename df. So what you do, first argument of rename is the data set. So rename df, and then the new column name equals the old column name. This is backwards from Stata. You go rename old to new. This is not the way it works in R, or at least with this function. You say rename the data set. What you want the new column to be called equals the old column. Okay. So you will not have two columns with MPG. This old MP. So as you see, MPG, the name of it has changed. Okay. It will give you, I believe, a warning if you try to rename something that doesn't exist. Or it might error, I don't know. I forget. Again, it's something I try very hard not to do. Okay. So this is really helpful, especially even if you're doing like 5 or 6 columns. It's fine. Like you would just have a big function that says MPG equals lowercase MPG, DRAT cap, comma, DRAT capital equals lowercase 1, and you go on and on and on, just separating these by commas. But again, if you wanted to do something like we were talking about before, where you wanted to rename every single column to the lowercase version, that's not super efficient, that's not super helpful. That's why that old way, or the other way using column names is still, I think, a useful tool to know. Okay, so does this make sense? New equals old. Okay. Note also, I don't have to put any quotes around anything. So Dplyr and these functions we're talking about are special. They're special in a way that if you put in a data set into these functions, it knows that what you're doing is on columns of that data set. Okay? They know that when you write MPG here and capital MPG here, you're not saying, oh, I define something, MPG equals something in R, right? Like X equals 5, like we've done that before. It doesn't go looking in your environment and says, I need to find MPG out there, right? It knows that when you write this, it means these are columns of a data set, okay? But with column names and other functions like that, you have to say, okay, we have to put quotes around things because they're treated as characters and stuff like that. So we'll get into that in a little bit more detail, but rename, new equals old. All right, so let's do some renaming. Let's go to the website, lab part 1, for data manipulation. Subsetting data in R. So it should be updated. Just want to make sure it looks. Nope, that's not what I want. Lab. Okay, yeah, so we're just gonna do part 1. So if you go to subsetting data in R, the lab, the key, because I revamped this a little bit, the key doesn't match 1-to-1. I would not jump straight to the key. The key is not going to be what, is not going to line up 1-to-1. Yes?
I have a bunch of things that I couldn't seem to do.
Okay. So did you load packages? So read CSV, you have to load in read R. You have to load the read R package. So library.
Yeah, that's what I did.
Yep. No. So read CSV is a function, right?
Okay.
So the package is read R, all lowercase. Okay, not try to read CSV. Yes. And then
So for write as well.
you have to put Dplyr as well. Sorry, what was the other one?
The write,
So-
underscore CSV.
That function is also in read R, so you should be.
Oh, okay, alright.
So let's say try library. Yep.
Alright, and the other one's,
Dplyr. So as
no,
that,
yeah,
that is in the Dplyr.
okay.
Yep.
do the Dplyr code
So that,
without loading.
yes.
Why is that the case?
Because you're super explicit to say, like, call this package, call this function from this package.
Right,
So
because then.
Exactly, that double colon is, you didn't have to load the entire package to actually call that function, because it's, hey, I know I want it specifically from this package, but I don't need it, so I'll load it up. But in general, starting out, you just use that.
Thanks.
So yeah, at the top, I would do these two things, just to be clear. Put readr and library Dplyr at the top, and run those before kind of trying any commands.
Okay, get a mirror message.
With Dplyr?
Yeah.
Okay, give me 1 sec. Okay. So you don't have a new version of Line. So you have to there it is.
I guess that is. I mean, I have an older version, but I just downloaded the new version. Maybe it's Okay.
Let's try that. Let's get it. Let's see what this is. That's our fault. Let's go. Reinstall our review.
Yeah.
I want to make sure Dplyr installs. That's going to be not that useful at all. But it should come in and see like the range on that.
Should I try and read?
Yeah, there's still, yeah, it's still, yeah. So,
How can you tell? Does it have like a?
so this little same thing up there kind of indicates it's still going on, right? Yeah. Yeah. That's part. Yeah, I think one of these B8
the
It's
same.
like you can go to help for columns. Just a question.
I don't know, just do it all.
So go to help. So if you see that, that means we're going to find something. When it's a sum two about it.
Yeah. Because there's not the equivalent in other languages.
Or it's a function on the left-hand side.
Yeah.
Usually it's more like
Right, yeah, exactly.
Just like sum.
What has an argument?
Yeah, it's kind of like, I mean, in my opinion, it's kind of the, there are some actual packages that do things where you like say like rename, like changes in, it does like in place, replacement, in place changes. So if you say like sort X, right, it actually reassigns it in the
Right,
background.
yeah, it's like a side effect, it's not just return.
Yeah. So that's kind of, I think, in some respects why this is made so that, because you could have just made a class where the copies like plus, but that's not how our kind of works. It doesn't leave all this copy in the background. So actually, for the most part, what it does, it says like, okay, data set, copy it with this new attribute set. But yeah, it's
Just,
yeah.
I always find it just interact.
Yeah, it's a very different syntax. Alright, so let's go over these real quick. So empty cars is a bit special, right? It's in this datasets package. So for those of you who use data, this is kind of like sysuse, right? There are system datasets that are kind of loaded up with R, so you can do them or use them as examples. So if you just write empty cars, you'll see that there. Note though, if we look in our environment, it's not there, right? That's because it is somewhere kind of in the system background because it's kind of one of these toy data sets. So although I can write empty cars, you can still see it plotted out. It's not necessarily going to show up in your environment. That's why we were saying, just reassign it to in the lecture. Let's say if we said df equals empty cars, if we run that command, look in our environment. Let's make this bigger. We see that df is now there. And it's the empty cars data set, and you can work with that if that makes you more comfortable actually seeing it in the environment, being able to click it. So, but what's the class of empty cars? Data frame. Exactly. So in the Dplyr package, this add.tibble. So if a command, for example, gave a tibble back, right after you applied this. We know, oh, great, it's Tibble. We have a nice way of displaying things, right? It doesn't print everything out, which is great, but one of the most crucial pieces of information about this data set, which car we were actually looking at, is totally wiped out because that was in the row names. So, I will show you how to create a new column that is equal to the row names, right, a little bit later. So how many observations, how many rows, how many columns? All right, so what did you use? You can look at it.
Look at the environment.
You look in the environment. How would you do with the code? Dim's one way, right? N row, right? N col. If you want to, so 32 by 11, 32 or 11. All right, somebody give me the syntax. Copy empty cars in an object called cars. So what do? Cars is equals empty cars, yep. How do I rename miles per gallon to the uppercase? So rename. So we can say, if we want it to be explicit, rename. Okay, what's the syntax? Okay, so I run this. So we got to put cars in there. And again, we're going to put cars, not empty cars. Oh, I didn't actually run this. Okay, that ran, but we want to resave it. So what do we have to do? Yep, have to do reassignment on the left-hand side. So now if I look at the head of cars, again, just the first few rows. We look at the first column, MPGs in all caps, all good. convert the column names of cars to all uppercase. Right? So we talked about to lower. There is a to upper. Okay. How can we do that? First, somebody give me a way to, I'm going to call it CN. How do I grab the column names? Column names of the data set, right? And if I just type CN, right, this is what we got. So now let's make them uppercase. So again, I said we can use to lower, or sorry, to upper. Let's see what comes out there. Great. Now what do we have to do?
Associate CN with column.
Now we have to associate again. How are we going to do that? Yep. If I write cars. Programming on the fly. Things you get. Okay. That's one way. Think that's probably one of the most efficient ways. If you want to do it in the really one-liner, but it's really kind of, it can be sometimes very confusing, you could do that. But those 3 steps, kind of see what goes on, right? And again, on comments, we could say extract column names, make them uppercase, reassign. That's good for teaching. That's probably not the comment you'd actually make in code, right? Unless you were starting out, right? Something like this, you'd probably just say reassign to uppercase, something like that. I use stuff like this, but I do agree it's still very, very convoluted. A lot of stuff going on there. And again, R evaluates from the middle out. So it says do column names, then do to upper, and then do the reassign. Okay. Let's say here I wanted to change, so I'm going to copy this again. Let's say I wanted to change carb to, let's see, cars. Carburetor. And change miles per gallon. What would I do? Instead of carb, I want to write the word carburetor out. Maybe I don't. I'll just put carbs because I don't know how to spell carburetor. I want to put an S on there.
Uppercase, you mean?
Nope. I don't want it to be called carb. I want it to be called carbs with an S. How do I do it in this command? Put a comma. Carbs equals carb. Okay? And again, white space is your friend and it's not your enemy. Like sometimes it's data. So new lines are not bad. So if I do stuff like this, it's really kind of ugly, but it's totally fine to do. If you highlight code in our studio and you go to code, you can say re-indent lines or command I, and it puts it a little bit nicer. So sometimes if you do that, you say, all right. Depends on what kind of makes more sense to you. But this is one command on 3 different lines. It's just organized in a different way to be more readable. So there's I don't think you can see it on here, but on your screen, actually you can't see it on here because this is too big. So I think this is like 80 characters or something, right? I personally try to have things where I don't have to like scroll left or right for hours and hours and hours when I have something super long. So I try to keep it kind of within half the window. Okay, so you can reformat your code if you'd like. Does that make sense to everyone, all the stuff we did there? All right, simple renaming. Good stuff, but, simple stuff, but really something you're doing like every single time you load in a data set. So now what you want to do is subsets and columns. I don't want everything in the data. I have like 1,000 variables. I don't need all that stuff. Okay, so one of the ways, you want to grab one column. There's a special operator for that, and it is the $sign. So df, $sign, carb, no quotes, don't need them. Grabs the carburetors and gives you back the vector of that. Okay? So if you want to grab one single column, the $sign is the way to go. Okay? So you're very explicit about what data set that is. If you just wrote carb, R says, I'm going to look in your environment for a thing named carb, right? Because again, you could have 20 data sets loaded in there. 2 of them could have the name carb. It doesn't know what to do. D, you have to say the data set, $carb. That returns a vector. Vector you now manipulate like every other vector, subsetting, histograms, plotting, quantiles, means, all that stuff. Okay? So $sign subsets 1 column. So, before vectors, we talked about bracket notation, bracket subsetting. X bracket 5 gave us the 5th element. Data frames have 2 dimensions though. They're not 1-dimensional. So we have to have a different, we still can use square brackets, but we have to have a little bit different syntax. The different syntax is bracket, rows, comma, columns. So whatever goes before the comma is trying to subset on the rows. Whatever goes after the comma, subsets on columns. Okay? And if we don't put anything there, it means all of them. So if we don't put anything before the comma, it means all rows. If we don't put anything after the comma, it means all columns. Okay? So for data frames and matrices, so matrices are very similar to data frames. The main difference is, like vectors, matrices have to have all the same type. So if a matrix has just has all numbers, it can be all numbers. You put one character in that matrix, the whole thing turns to character, just like we did with a vector. Data frames can have different things in each column, right? Age is numbers, the second column is the address, right? And so on. They can have different things in each column, just like a regular spreadsheet. Matrices are different. They have to have all the same type in them. We're not going to talk about that too much. They're not as easily manipulatable. Dplyr doesn't work on matrices. It only works on data frames and Tibbles. So we're not going to use those. But I'm just saying, matrices, this is the way you subset those as well. We'll talk about them very briefly, but they're not as useful because that's not what you're using on the day-to-day for your data sets. All right, now we can grab a column 2 ways. One column, again, we can use indexes. So df bracket, comma, 11 means I want to grab the 11th column. Gives me that lovely vector. The 11th column happens to be the carburetors. Remember, this is a 32 by 11 data set. df bracket, comma, I don't want to subset based on, which index. That might change. I'm going to subset based on the column name. You can say carb. Totally fine. This is the base R way of doing things. Note, though, you have to put in quotes. You have to say, this is the column, and you have to say, this is a column of the data set. I want to grab it by its name. If you wrote the word carb there, what R will do, again, it will look in your memory and say, is there something named carb? If not, I don't know what you're trying to do. That's why you need quotes around it. That's how you can grab one column. So, the other big difference between data frames and Tibbles is if you grab one column with brackets like we just showed, it will give you a vector. Sometimes that's what you want, sometimes that's not. Right? Because let's say you have some code where you might select based on something. Let's say one iteration of the code it selected 3 columns, one iteration selected only 1 column. When you select multiple columns from a data frame, you get a data frame back with 3 columns, let's say. What happens when that code changes and it only grabs 1 column? If you wanted a data frame back, you are going to be sadly mistaken. I just showed you they give you vectors. Tibbles, on the other hand, always return a tibble. So data frame, comma 1, vector. Tibble, comma 1, tibble. So this has rows and columns. This happens only in 1 column, but it has rows. So if you say n row on this, you get a number. You say n column on this, you get 1. You try that on this, it doesn't work. That doesn't work for vectors. There are times when you usually want to do this, but for the majority of the time, if you're grabbing 1 column, you use the $sign. Okay? There's different behavior. This is usually what you want. You don't want it to change the structure of your data. You don't want it to make it something different unless you're explicitly using that to pass into some other function like plotting or something like that. And most of the time, you know which column you want to do. Therefore, you use the dollar sign anyway. Okay. So, differences. Now, again, like we did subsetting with vectors, we can subset on multiple things, not just one. So if we want to say, I want the 2 columns, I want MPG and cylinders. So again, we still have to collect things in a vector, right? We can't just write df, comma, MPG, comma, cylinder. Doesn't understand that. It says rows, columns. And if you put another comma there, it means something completely different. So we say all the rows, these 2 columns, right? But I want to say this whole vector of column names. So before, we could just put carb in there. But if you want multiple things in there, you have to use the C to collect them all together into a vector, and then you subset. So the way you do this in Dplyr, pretty much simpler. Select. You select columns. Select the data set, the column name that you want. You don't need quotes. Don't need any of that stuff. I'll say you don't need quotes as long as you have sensible column names. Sensible column names meaning you don't have, your column names don't start with numbers. Your column names don't have spaces. Your column names don't have hyphens. Your column names don't have strange things that are not allowed. Or they are allowed, but then you need to be careful with them, let's say. So if you have just letters and numbers, and you don't start with a number, it's fine. Select MPG. Gives you a data frame, or gives you a, this will give you, select will make sure to give you a data frame back. The bracket notation, totally different. Select, you give me a data frame, you subset only one column, I don't care. I'm giving you a data frame back. Okay? You want multiple columns? Put a column, put as many as you like. Right? So this, to say to people, is keep. Did we talk about here? Okay, sorry, didn't say here. There is drop. The only difference between drop and keep is you can put a negative out in front of us. So you could say df mpg minus cylinder. Or you could say select minus mpg. What that will do is it will drop miles per gallon. So like we said before with negative subsetting, I don't do that too much on indices, but you can say select df minus mpg, nothing else. That'll give you the exact same data set back without miles per gallon. Okay? All right, let's do some selecting. So we should go to the lab, set part 2. Sorry, before we go there, go to the help file for select. Do question mark select. There's a very relevant area. Okay? So, again, it gives you this description. It gives you a rather confusing set of arguments. But there is a very important section called useful functions. These are very useful. So, you can use these in select. Starts with, ends with, contains, matches, num ranges. And again, it says to drop variables, you can use the negative sign or the hyphen. So, let me see if it shows you. It should show you an example. So, in this data set, iris, I'm going to take this code and run it. Well, let's see what it does. It selects on this data set variables that start with pedal. So you don't have to know if it's pedal 1, pedal 5, pedal underscore whatever. You can just run this. So here, get out of there. So there's pedal.length and pedal.width. So if I look at all of iris, there's sepal.length, sepal.width, or pedal.length, pedal.width. So when we say starts with, and we put in quotes, It's saying, look at this string, grab variables of this data set that start with the word pedal. Okay? So, it is also case independent if by default, I believe. If you say pet, still fine. It still starts with pet. If you say nothing. So this is sometimes might be what happened. You see a Tibble, and it says 150 by 0. Means you have no columns. Means you didn't select any columns. Okay?
So, how do you get yours to just display the first 10 rows?
So in this command here, I copied this. Iris, it converted it to a Tibble. So Tibbles by default only show the first 10 rows. So similarly with starts with, ends with, you put in quotes a string that you want a variable to end with. Similarly, contains, you put any string in there. Like I could put, let's say contains an I. Sepal with, pedal with, species. Contain an I. But it must contain an I and a D. Species contains an I, but it doesn't have a D right after it, so it drops it. So this is similar. Contains is similar to like star, string star. Starts with is just name star, and ends with is star ending in Stata, right? For wildcard matching, that kind of stuff. Okay, so let's subset the columns from empty cars that ends with a P. Whoops. So we're just going to do number 6 for now, because I think we have to jump to... Actually, skip over number 7 for now, because we have to do filter on that. So you had to, TBL isn't, you had to define that. In the code, we define that as like empty cars as like we use as.tbl. So if you say TBL equals as.tbl equals as.tbl and then empty cars.
And then do
Or TBL1. It's just there's an A there. Take that out. So show you that it now has rows and columns and not just one vector. So if you say cars, back to column 1. Yep. It doesn't return a data from it returns a vector. It simply returns columns using brackets.
Thank you.
So actually, in number 7, do number 7. Just don't worry about the 8 cylinders part. So just create a subset of the data that just contains WT, QSEC, and HP, and call it car sub. All right, so who wants to take a crack at PVARs? Number 6. Does what everybody else have? All right. So we took out the cylinder requirement. Let's make car sub.
Car sub equals select parentheses empty cars weight qsec.
Yep. What's the dimensions?
Uh,
How do I get the dimensions? Without looking at the environment.
view.
Hmm?
View.
Without, yeah.
Dimensions.
Oh, right.
Dim's one way. Yep. Dim's a good way. 32 by 3. Still 32 rows. All the rows. So again, this last part, exactly the same as we've done in the last section. You can say column names, car sub equals 2 upper, let's say column names. Car sub, to have the kind of confusing way, the code above is a simpler way. So now we have car sub, just those 3 columns. All right, let's take a look at them. WT, QSEC, HP, all caps. Okay? So, yeah.
Sorry, I think I missed something. For number 7, isn't it just for cars that have been sold?
Yes, but we haven't done that yet.
Oh.
So yeah, if you so that is filtering. So that's what we're going to talk about now. So again, subsetting columns, great for paring down data, getting a look at your data that doesn't, overwhelm you. Especially, again, I tried to load up one of the data sets from DHS, and its data was like, too many variables. So, usually looking at 1,000 variables isn't very helpful. So you want to subset it based on some way. But subsetting rows really is where all the money's at, more or less. Filtering based on some condition, doing some sort of operation based on a subset of your data, removing missingness, that kind of stuff. So subsetting rows, bracket notation, same deal as it was with columns, just you put the row subsets first. So it's df, bracket, and again, when I say df, that is an actual data set in memory. Right? df is not some generic thing in R. It's something we actually define. df bracket, C13, comma, nothing, and bracket, which means I want the first and the third row of the data set, all the columns. Okay? So the Mazda RX-4, Datsun 710. Okay? So most of the time, that's not what you're doing. Most of the time, what you're doing is subsetting based on a logical condition. You can do it just the same way you would with vectors, just you have to make sure, or you should ensure, that the length of the logical thing is the same length of your data set. That is easy to do when you're using columns in that data set. So what are we doing? We're saying df $MPG. Grab the miles per gallon column. Is it greater than 20? Or is df miles per gallon less than 14? So we don't want anything 14 to 20 inclusive. Anything there, throw it out. Everything at the tail ends. That's what we're doing here. And then we put that'll give us logicals, trues, and falses. Right? We can put that in the indexing spot or in the subsetting spot for rows, comma, I want all the columns again. Now we have, as you see, miles per gallon, 10, 32, 30. These are the cars with less than 14 or over 20 miles per gallon. Okay? So now, it should be clear to see that if you want to do a series of operations of filtering, this can get big. Or you do this in a lot of sequential steps, which is totally fine. With bracket notation, you can do both at the same time. It's totally fine. You say, okay, I want only those cars that met that condition, but I only want the cylinder and the horsepower columns. Okay? One fell swoop, subsetting rows and columns. Now, the Dplyr way, the easier way, is use the filter command. Select selects columns, filter filters rows. Filter the data set, and then you put in MPG greater than 20 or MPG is less than 14. Note, we did not put a comma there. It is not the same thing. We put that logical condition. So filter, you have to give it something logical. You have to give it a logical condition. It doesn't accept indices. Okay? Also note, we don't have to do anything with dollar signs. When we're using Dplyr commands, it knows that when I say MPG, it means the MPG column from that data set. Okay? Same exact thing. But look at this, and then look at this. What's different? What car is this? I don't know. Row names are gone. So, again, if you have row names, get them out. So, filter does a little bit different things. It doesn't necessarily return row names. So, filter is the command you want. You can put column names, I'll call them bare, where they don't have to have quotes around it, you don't have to have dollar signs, so bare column names. And that's the way you really put things together. So, we had to put that pipe in there to say it was this or this, right? Because filter, we could put in miles per gallon is greater than 20 and the cylinder is equal to 4. So let's see, we're a cylinder, we're all 4-cylinder engines, miles per gallon, they're all greater than 20, right? Compound logical statement, totally fine. If you're joining things by and, right, this and that and that and that, you can separate them by commas. That's fine. So you're saying, I want data frame where miles per gallon is greater than 20 and the cylinder is equal to 4. You can string them together by commas, totally fine. Filter, when you put multiple conditions in there, it says and, right? It's the intersection of those things. So if you need something that is an or, you have to be explicit about it. You have to define that logical statement. So if you want like this and cylinder equals 4, you can put a comma here and say cylinder equals 4. It's totally fine. Or you could put an ampersand for the and operator and do that as well. But if you want to do something where it's a bit more complex, you have to change it up. Okay. There is something a little bit about logic, which I think a logical operator that we haven't really touched on. So again, this is the exact same thing. This does the exact same thing. I don't know if I have df defined. Yes, I do. Okay. This, without the parentheses, are totally fine. Okay. Now, we come to this a little bit later, but I think it's good to introduce it here. That negates it. That's the opposite. Everything that was true is now false. So not. So if you had this condition where miles per gallon was greater than 20 or less than 14, right? So it's, so let's say, this is probably not the best example. Let's do this. Let's do this. So miles per gallon is greater than 20 and the cylinder is equal to 4. Those are all bad cars. Hate them. Let's get rid of those. That's what this does. So it says, find this condition. Wherever it's true, flip it up. Trues or falses. Just a negation. Okay? So wherever it was true is now false. Sometimes it's easy to write a logical statement and then write not that. Right? You might say, you know, especially, so this is kind of a way you drop those rows. Say, I want to find these ones and get rid of them. Okay? right? The other, so this condition and this condition are exactly the same, I believe. Maybe that might not be true. Yeah. So sometimes, I don't think that's the same. Nope. Get rid of that. Okay. So this throws out all 4-cylinder engines, regardless of miles per gallon, right? The other one will not. This throws out, if you have 4-cylinder engines, you're gone. Right? Doesn't matter your miles per gallon. But if you have any cylinder engine and you have greater than 20 miles per gallon, you're still gone. Right? So doing that, right, in let's say an affirmative way, using a keep mentality is a little bit harder. Sometimes it's like, I don't want these versus I want all the others. Right? So the bang or the exclamation point is the negation. It can flip things, but we still have to encapsulate things in parentheses for that. Okay, so let's go to the next set. So we didn't. So let's try. Let's actually go back to number 7 and do that filtration. Do the filtering. Right. So we grabbed the 3 columns that we wanted. Right. So we already did the steps here. Car sub, all that kind of stuff. We made it uppercase. Now before we start part 3, just filter it so that you only have 3 cylinders. Oh, no, can't do that. That's a lie. Don't do that. Because we dropped the cylinder column. Just move on to number 9, and then I'll circle back to that. Because it illustrates a specific order of operations thing. Alright, so if you can give me a start to this, subset the rows, more than 20 MPG. We're using car sub here, by the way.
That one doesn't have MPG.
That one doesn't have MPG? Okay, never mind. Use empty cars. Or cars, because they should be equivalent. They're actually not. All right, somebody give me all right, greater than 20 miles per gallon. So we're gonna use filter, right? Let's say you use cars, right? So what are we gonna say? Miles per gallon greater than 20, right? Nope. At least not for that. This is what comes up. Evaluation error, object MPG not found. It's because uppercase, exactly. So the Dplyr commands will tell you you're trying to use a column that doesn't exist, which usually means you've changed it, or it's a typo, or something's going on a little bit differently. Okay, so we can get those empty cars because MPG is still lowercase. We could use that as well. All right, so I'm gonna let's. What about subsetting? They get less than 60 miles per gallon and have more than 100 horsepower. Let's use empty cars so we don't have to use uppercase. So MPG, less than 16, right? And HP, greater than 100. That's one way to do it. We could just put a comma here too. Totally the same. If this was or, we'd have to put the or in here. We couldn't use the comma. Okay? So we're going to pop back to this in about 2 seconds because I'm going to talk about what happens when you want to combine the two. Yes?
Can I ask a question?
Yeah, of course.
When you're filtering, when would you, I guess, do something equals to filter, so making a new data frame?
So yeah, if you want to subset the data, right? All we've done so far is plotted it or printed it. We haven't actually subset and saved it at all.
Okay, so you just do filter bracket, blah, blah, blah.
You say like df2 or df equals filter.
Okay, so it's not dropping.
It's not actually doing. It's not doing. Good question. It's not doing anything to the data at all.
Okay.
But if I say empty cars 2, because I just don't want to. Or let's say cars is actually this. Cars now has only cars with more than 20 miles per gallon.
Oh, okay. That's what I did because I thought that if you did that, it deleted everything or dropped everything else.
So yeah, if you just say filter, exactly. If you say filter or select or anything like that, it just shows it, just displays it.
Okay.
Doesn't do anything to your data set. Good question, right? So a lot of times, like we showed before, you could have done that logical condition where you say bracket, row condition, then column condition, whatever. But most of the time, you want to do these in conjunction. But they can get pretty complicated and look pretty ugly. And again, middle out is the way R kind of evaluates things. So here, filter data frame. Miles per gallon is greater than 20, and cylinder equals 4. right? Return that data set and then pass that into select and select these two columns. Now, why can't I switch the order of these operations? They have to be done explicitly in this order. They don't always have to be, but this one does.
You mean the order filter within select?
We don't have to always do order, filter, and select, but if we switch this up, what are we doing?
You're dropping out.
We're dropping miles per gallon. So, it's totally fine to do it in order, to do it in whatever order you'd like, but sometimes it fails because it'll say, that's not existent. You look at the data, it's there. But in your command, you're actually selecting it out and then, so you can do select and filter. But you can't do this select and filter at the same time without additionally then dropping the MPG that you didn't want. Does that make sense? So this one, we can change the order of operations, no problem. But this if condition requires that this data set has a miles per gallon and a cylinder. Okay? So, again, it's common to perform multiple operations to wrap functions around each other in nested ways as above. But that gets pretty ugly or pretty confusing really quickly. We've already shown you one way to do that, or another way to do that is to do operations in sequence. Okay. So this case, you don't have to make it something new. We could have changed this to DF. In this case, I'm just making it another DF, DF2. It's not usually a good idea to copy your data. I mean, it's not a bad idea, but you usually just want to say, like, why am I copying my data? Do I actually need this, all the data, or I only care about this subset? Why not just replace it? So we're filtering, then we're selecting. But again, if we change the order of these two, then we would say, oh, I don't know what MPG is. So there is a third way to do it. It's called piping. And it's not the pipe for the logical operator. It's a different type of operation. So this is newer, I think a bit more intuitive after you kind of get the hang of it, and it reads much easier in code. So this is the way it works. You pipe the thing on the left into the right. Pipe flow to the right. So you say df, you pipe it in to the filter command. Okay? You don't have to respecify. So before we said filter, parentheses, data frame, operate, or logic. Here we say, pipe this in there. It'll do the filtering, right? So this, regardless, this does the filtering. And then we're like, oh, well, I want to keep doing stuff. I don't want to like make an intermediary copy. That's just annoying. I don't need that. I know I want to do a whole bunch of operations at once. And then you pipe the whole thing in a select. So the operation goes in order. You don't have to like look at 100 parentheses and say, where does it start and where does it end? Right? It says data frame or filter, then we're selecting. That still doesn't always look that great, I believe. We'll come. I'll jump back to this in a minute. But the nice thing about this is when you do something like that, that, to me, reads a lot easier. Also, you can still write, remove those bedrooms, right? Keep good columns, right? If you want to be very explicit, like, what am I doing? Why am I doing this, right? So that, at least to me, at least reads a lot easier. Makes a lot of sense, at least to me. So this operation, the pipe, is a percent greater than symbol percent. You don't have to write that out. You hit Command-Shift-M or Control-Shift-M in our studio. Try it out. Command-Shift-M. Control-Shift-M. Depending on what keyboard you got. So I usually do 2 right fingers for the command and the shift, and then the left comes over for the M. That actually makes less sense. But I don't know. That's how my hands think. And it should come up. Command or Shift M. You get all these, right? Or Control Shift M for Windows. So,
Let me just open
Control Shift M. M.
Oh, and
M as in Mary, not Nancy. Sorry.
I did that too.
Yeah, okay. Just 100 windows. No. Okay, so that's the pipe. And we're going to use that a lot in the following lectures because we're going to be doing a lot of operations. Like, for example, we're going to take a data set, we're going to filter a few rows, we're going to group it by a new variable, do some sort of summarization, and then get it out. Okay? So, Controller, Command-Shift-M, and that's kind of the new way of kind of data manipulation, kind of workflow. Right, so I would say a lot of people still do this. I still think that's totally fine. It's just sometimes like reassigning. You only have to reassign once. Like we didn't reassign anything here, but again, if we say again we have reassigned nothing. Nothing has changed in the data. This is just showing us the output. If we said df equals this, it will have filtered and selected at the same time. Okay, but again, if we switch these up, boom, it's gonna fail. All right. Let's add some, or remove some columns. Actually, do some really data manipulation. So the df $, kind of like column names, it extracted stuff. You can also reassign it, or you could reassign it or assign new things. Again, there's no gem replace, any of that kind of stuff. So df $new column equals df $weight divided by 2.2. So the weight in pounds, we want it in kilograms. So this extracts the weight column, divided it by 2.2, and now it assigns it to a new column of the data set. So you see the very, very end, boom, new column exists. Okay. So the $, if you're creating one thing at a time, it's one way of doing it. A way of dropping a variable, just one. Again, we can use select with the negative symbol. We talked about that. But still, a lot of people, including myself, remove columns. You say df $, the column name equals null. Just get rid of it. Again, if that doesn't make sense, don't worry. Just throw it out of your mind. Use select.
And sorry, so this is operating directly on the data frame.
This is operating, yes. So this is assigning a new thing to the data frame. And doing nothing else to any of the columns, but yes, it is. We'll call it mutating the data frame.
Okay.
Yes.
So to achieve the same thing, can you just say new column equals weight divided by 2.2?
No.
Because it's the data frame.
Because it won't know which data frame you're doing that on. At least, wait. So there's a Dplyr command called mutate, which you get in a minute. But again, this I'll say like a lot of people have adopted a lot of these new ways. This is like, I'm saying like, oh, like, maybe half people are doing this. Still like 80% of people still like do stuff like this. Or mix and match. So I think this is still very common. Again, things you can do, subsetting columns, column names, every column name, but that's a way you can drop a column, right? But that's only if you want to just subset one. Again, this is like if you were saying select with the negative symbol, I'll go to the next slide and it'll be there. Or I want to get all the columns except for the column name that doesn't equal new column. Again, a different way of doing it. We're not going to look at, I'll go back to cbind, but I want to move to select. Mutate. So mutate is the function that you're talking about. So we say, we select columns, we filter rows. We can also mutate the columns, which means you can either add new columns or you can change existing columns. The way that is, column name equals, what do you want to define it as? If new column was already defined, it would just overwrite it, just like everything else, right? You can think of it as a replace. It always allows replace. So it's a gender replace altogether. So we're mutating this data frame, we're reassigning it. Actually, if we didn't reassign it, that column would not have been added. It would have just been added and printed out. So reassign it, data frame, new column equals weight divided by 2. We don't have to do $signs and that kind of stuff in mutate. Yep.
This is completely different thinking from this data, I think, but a lot of the complexity comes from the fact that you're working with multiple data sets and or
Yes.
data frames at the same time.
You cannot do it where you only work with one.
Yeah, can you just specify, upfront, I'm working with this
No.
data frame?
No.
And the rest of it?
No.
No, okay. So you're gonna have to repeat what data frame you're working with every single time you write a command.
Yes,
Essentially.
because that allows you the flexibility to have other things like models and other things in there so that you can reference those things. There is a thing called attach. Okay? Attach will allow you to write things like this all the time.
do not use it. I'm just saying, if you find something online that's like, oh, he never told us about attach. I told you about it because it's bad. It's bad because you can sort vectors. Like if you attach this, they're not bound anymore. Like so what's called attaching, it creates a variable in your memory, every single variable for the columns of your data set. But you can do stuff to them. You can reorder one, and it doesn't reorder the rest. That's why it's bad. Keeping it as a data frame, you order the rows, it reorders. You reorder the columns, everything's still together. So attach exists, don't use it. So okay, this is the way you do it. And again, you put comma. You can define 100 variables here. It doesn't really matter, right? You could say comma new col2 equals qsec divided by 5, or whatever. Again, select. You can put negative symbols or negatives on there to drop a specific comma. Yes.
Suppose I have a huge data set like
Mhm.
with DHS and I want to drop some of the variables, like and select the subs.
So you wanna good question. So you can drop variables that's so remember we use starts with, ends with? You can use negative on that as well. Right? So matches, contains, all that kind of stuff. All those useful functions in select. So look at the help file for select. Find out like I don't want anything that's like HV02 anything. You could say minus contains HV02. And then it'll say anything it sees there, get rid of. And it'll drop all those. Right? One of is another one where it's just more explicit. If you want to say drop, if it's new col or drag, right, you could just list them out that way. Right? If it's one of these.
Instead, I have the dash, right? Like if you want to select from one variable to.
You can do that. Again, I've never, even when I use theta extensively, I never use that.
Okay.
You can. It's the colon operator that we talked about before. You'd say variable, colon, start variable, colon, end variable. And you put parentheses around it, put a negative in front, just like you did with numbers.
Okay.
So it'll do a negative indexing. It'll do it in select. Use at your own risk. I just assume, I don't know why, I assume there's people out there that one day are just going to shuffle all the columns of all the data I've ever used and just break everything. And I've been more confirmed by that than denied. They haven't done exactly that, but some of my collaborators have done some inventive things with data, let's say. Or just they're like, the data's going to stay exactly like this. And then, 6 months later, it's like, it's going to stay like this now forever. And then they're like, 3 months later, like, all right, so like this happened. And I'm just like, okay. All right, we will go to the lab really quickly. All right, so now we want to reorder columns. Right? Just want to order things around. I think it's order instead of, I forget. Yeah, order. Yeah. Okay. Nope, not even going to show you that way. That way sucks. Okay. Back to select. So there's another useful function in there called everything. So one of the ways you do it, you say select. You put the columns that you want in order, and then you can just say everything else, keep it in order as it was. So we created that new column, which was weight divided by 2.2. We wanted weight in kilograms. We said now, give me that data frame, new column be first, and then everything else, keep it as is. So this is order, where it's like order, new call star. Right? Before I do it, everyone in here has used data before, right? Okay, so there wasn't someone who was like, I don't understand it at all. Like, if they're like, I'm a SAS person, or like, I'm only SAS, right? No one's okay. If you're at the school and you've, usually you're not that. But there are people that like, nothing you're saying makes sense. So, okay. Order, new call star, equivalent not. Okay? Ordering rows. Okay, this is 100% the reason I don't teach everything in base. This is the only time we'll keep coming back to base for the most part. This is the one command. Because this is how you order things in base. Do not look, it doesn't matter. Don't look at it. I'm just saying, don't look at it, don't like learn it. Just look at it. To me, this is, to a new user, one of the most confusing things that you can possibly make. Because you have a data frame, you have bracket notation, you have a function inside the brackets, you have $sign notation, and a parentheses, and you have a comma with nothing after it, and then brackets again.
To a seasoned R user, this is the bread and butter. They do this every day. The reason I hate this is a lot of reasons. That's a lot of stuff going on. That is 2 different types of subsetting. And this doesn't work very well with characters. That's all. No, get rid of that. Don't care. Don't care. Command you use is arrange. To reorder rows. To sort a data set. You use arrange. And the way it is, you say data frame, whatever column you want it to arrange by. By default, it'll be in ascending order. Right? Smallest to largest. If you want to change that, the DESC command, like those other helpful commands we had before, one of, all that kind of stuff, that says, I want to sort it, but decreasing on this. Okay? So,
That works for both strings and
that works for both strings, works for strings, factors, logicals, numerics, all that kind of stuff. So it will sort things by alphanumerics. If you're sorting like a categorical variable, I would suggest, as we'll talk about later, making it into a categorical variable with specified levels, like a specified order to begin with, if it really matters the order in which they're in. But yeah, so descending will do that. Now, also, I want to order by 2 different variables. First, by miles per gallon, and then decreasing horsepower. All right, this is a terrible example. No, it is still a terrible example, but these 2, 15.2 miles per gallon. Let's look at the horsepower. Are they the same? No. 180 comes first. Because it orders by miles per gallon, then decreasingly by horsepower. Or descending, right? So it doesn't matter. It would be like ID, visit, descending blood pressure, or whatever. Right? So you just arrange and keep going however way you want to sort it. But sorting does matter, right? A lot of times when you do a whole bunch of stuff. Especially if you want to grab the first case and all that kind of stuff. All right, transmute exists, but it's kind of this like weird hybrid that combines like mutate and select. So it's like you can define a new column in here and then just specify other columns you want there. To say like, oh, I want this column and I want these other ones in there, and then drop everything else. I don't generally use that. I'll use mutate or select explicitly. All right, so really quickly, what does select do? Chooses columns. What does filter do? Chooses rows. How do you sort a data set? Arrange. How do you rename a data set? Rename. Right? These aren't like trick questions. How do you add? How do you change a column or add a new column? What's the Dplyr function? Mutate. We haven't talked about it yet. We will talk about it later. How to change a existing column based on a condition. Right? Like replace age if it's greater than 80 equal to 80, for example. We haven't shown that yet. No, it's a different process. Yes.
Arrange is to try to sort the observations. But now, if you want to sort the variables,
Sort the columns.
columns.
What is in like you want an alphabetical or something?
Yeah, if we have a variable 1, 2, 3, but we need the first one, the fourth one in the first position.
Mm-hmm.
How to sort the variable order?
You can do that. I would most likely do that with the standard way with column names, and I would make it like CN is the column names, and then I would do something where I'd sort that vector. And then subset based on that, right? That like if I did like that CN and then sort CN and then subset based with like brackets like we did before, that will sort everything in alphabetical order. That's a good question. Yeah, I'll have to think about that. To how to like get those specific columns sorted in a way. Mostly, if you're viewing it, that makes sense. But if you're doing it that for like reshaping and stuff, you don't have to worry about that. That'll work okay without like sorting them. But for viewing, I agree. All right, let's go to the lab. Let's take about 10 minutes to do this. I think, depending on how many we have. We only got 2 questions. Yeah. So yeah, and also if you have any indication, like if you think piping makes more sense or less sense, let me know. So we always usually have like kind of a mixed bag there. Yeah. I?
Yeah, this is one of them.
Well?
Do you want us to recreate car sub from cars and then?
No, just use a car sub for now.
I see what you mean.
It's just been created.
Yeah, it should be already
So that's-
created. Yeah, so just to get I mean it's okay to still do it in one line. I'll describe why I think piping even for one is relevant. All right. What about reordering the rows of car sub by weight in increasing order? We set a range, and then what? What am I putting? Comma, and then just wait, right? So gives it back. But let me see. Let me run what I had up here. Give me 1 second. So what happened? Car sub. Great. Arrange. Oh no. No row names. So I did tell you that I'd show you a way to get that data actually into a column. So row names, right? Would extract those out. So here I'm just going to say cars2 equals empty cars. So I'm just making another copy just for illustrative purposes. So we can do, like the way I showed before, cars, $car, I'm creating a new column, equals the row names of that data set. So now if we look at that, sorry. Let's look at it. Here, I'll use view. It might be easier to see. So we look down the line. Okay, they're all in there. Okay, so if you do happen to have row names or something like that, this is the way you can do it. You extract it. It's just like a regular string. And now we're assigning it to a column in the data set. And then, like I was showing before, this is a way you can do piping, right? So that was the question we had, but we couldn't necessarily do it yet. So we said car sub, and this is going to be different from what you've done. Cars2, we're going to filter 8 cylinders. I'm going to select weight, QSEC, horsepower. And in this case, we want to keep car, so we actually have some record of what cars we're actually looking at, and then make everything capitalized. And then we can do, for example, order them by weight. So we see the Ford Pantera is the lightest one. The Lincoln Continental is the heaviest one. Okay? So let's create a variable in car sub using MPG is equal to MPG squared, the capitalized, using mutate. So I'm going to do it this way. And what am I going to write? MPG squared equals MPG? No. Doesn't work like that. New one equals old one. So the reason I'm going to show you about the pipe. Oh.
Yeah.
Trick question. Make it weight squared. Sorry about that. Okay, great. That works. So what I want to show you is something that's very helpful. Cars sub, and I hit tab. So remember, when you're in a function, you hit tab. It tells you the arguments of that function. Great. Not so helpful in this case. But piping has an additional benefit to looking good and being able to sort things and being able to see things better. So when you say dataset pipe into a Dplyr function, and I hit tab in here, why is it not? Hold on. You should be, if I pipe it, and you scroll to the bottom. So if I'm at the top, it says like, oh, these are the arguments. If you hit up, it'll go to the bottom, and it will show you the names of the variables in that data set. If I do that here without doing the piping, it doesn't show me that. So piping, when you're piping, it says, oh, I know you're working on this data set, so I'll give you a quick lookup table if you hit tab, and I'll give you some of the names. The reason these are at the bottom, I believe, is because they are capitalized. If I said like empty cars mutate, no, I'm wrong. Nope, they're still at the bottom. But if you use piping in a Dplyr function, you hit tab inside of it. It will give you an indication of the column name somewhere in that tab completion. All right, so then we can just do weight equals weight, and if I start to type it, it'll come up as like something nice. Weight 2. Okay. Another reason to use piping. All right. So I think I delivered on all the promises. Show how to get row names as an actual column. Why piping exists. Let's do some piping, and then yeah.
Can you go back to this one?
Yep.
What does the Ben sign? What does the exclamation sign?
Ah. No symbol WT in scope. That is because the thing going on in the background in our studio, it's trying to just give you like a heads up if there's some weird stuff in the code or things that might be errors. It is not an error, it's just a warning. So what it's doing is saying like, hey, you didn't put any quotes around this, you didn't put any dollar signs. So I'm looking in your environment, and I don't see anything named WT. So it's saying like, I don't know what that is. Are you sure that's defined? And that is a byproduct of like these things being really useful, that you don't have to put quotes, you don't have to put dollar signs, all that kind of stuff around it. But that is kind of a byproduct of that.
So
You can ignore it. Correct. Red stuff, don't ignore it. But sometimes, let's say like you say like x squared, stuff like that. It's like no symbol in your scope. So it's just saying like, hey, like I don't think you defined this. So if you see some errors, like check those. If you see errors, like check those out first. All right, I'm going to run through some summarization a bit quicker because one, it's relatively straightforward comparatively than some of these data manipulation sets, and I'm going to get through at least some of this, so we get to at least 1 or 2 lab sections before the end of the day. All right. Nope, can't go. Nope. All right. Basic statistical summarization, more or less. If you want to do it, there should be a function or a way to get that estimate. Okay, mean, standard deviation, median, quantile, range, sum, passing in vector values. Gives you that back, right? Mean is mean, SD, VAR is var for variance. Quantile, by default, it gives you the quartiles of a data set plus the min and the max. So 0, 25th, 50th, 75th, 100th percentile, right? Min, actual, and max. Range gives you 2 numbers back, min and max. Okay. Sum adds everything up. Sum is really useful, right? Especially when you're doing logicals. You sum the number of logicals, that tells you the number of cases where it's true. Okay. Some transformations: log, log2, log10, square root, absolute value, all that kind of stuff. I don't know off the top of my head the box-cox transformation function on there. I would literally just Google box-cox R, and then it'll tell you like probably like bcox or something like that. I don't use it that much, but these are definitely really useful, especially for plotting, right? Especially with really skewed data. So again, head we've been using over and over again, right? It just shows you the first 6 values. That's the way I usually view my data. View is a really good option, but it wasn't always around, and I'm so conditioned to using this. That's why head is there over and over again. If you ever see head in the notes, though, usually the only reason we did that is so it didn't scroll all the way to the bottom of the screen, so we can actually show you. All right, mean. Just pass in a vector. How do we get a vector? Take empty cars. Take the dollar sign operator. Get HP. Mean horsepower. 146. 146 horsepower, right? So again, dollar sign grabs the horsepower. Mean gives you the mean of those values. Quantile. Again, defaults. So the min, 52. Max, 335. Median's about 123. Other quartiles right there. Okay? Gives you back a vector of those numbers. So you can reassign that to something else called like quant or something like that, and play with them, plot them, do that, all that kind of stuff. So everything here can be returned. You can assign it to anything you want. Okay? And that is just a free-floating object that has no bound to your data in any way. It's just a number that you can save to disk or put in a plot or whatever. Median, similarly, that's the median. But this we're doing on weight. Quantile, by default, again, they'll do all min, max, 25th, 75th, and the median. This, it takes another argument, probs, for the probabilities. Like, what quantile do you want? So I want the 60th percentile. Okay, put in probs equals 6. I want the deciles, right? We can do that. 0, 0.1, 0.2, 0.3. And I'll show you an easy way to make that sequence from 0 to 1 at 1. Again, we'll get to statistical summarization a little bit later, but if you want to take means and you really just want a confidence interval off the bat, just something super straightforward, you can do t.test. Just a t-test. Really what you want, if you want mean, standard deviation, or confidence interval, it'll give you that. You could have used SD, that's standard deviation, done the calculation by hand or whatever like that. You always do that. Now, missing data. It exists. Pretty much always. The way missing data is coded in R is NAs, for the most part. There are two or three other conditions, right? NaN, when you try to divide 0 by 0, it's not defined. That doesn't make any sense in math. Right? If you try to divide a positive number by 0, you get infinity. Try to divide a negative number by 0, you get negative infinity. Those are other three cases of, I'll say, weird data. Non-finite data, right? But for the most part, if you're missing data, it's an NA. No quotes around it, nothing. NA. Okay? So, if you use any of those functions that I showed on the first page, mean, standard deviation, range, max, or quantile, and you have missing data, those will all return NA by default. The reason they do that is because it says, hey, you have missing data here. You should be aware of it. So if you have missing data, bless you. If you have missing data and you try to make some summarization of it, I don't know, that's not really defined well. I don't know what that value is. You better be aware you have missing data. So it'll always return missing. The argument that tells you, okay, I know I'm missing data. Calculate the mean anyway, just remove those points. NA.rm. NA.rm. Right? NA.rm says, hey, calculate the mean of data that's there. Calculates it's fine. The denominator is the correct number of points that are not missing. It doesn't treat them as 0, none of that. It wouldn't do any of that, strange stuff that sometimes Excel loves to do. Quantile, similarly, this is the quantile of data that's there. Okay? So again, this one missing point will give you NA if you try to use the standard operations on there without saying NA.rm equals true. There are means, sums, all that kind of stuff. There are specific things that will do rows or column means, column sums. Row means, column means, row sums, col sums. Pretty much you have to pass in something that's all numbers or logicals, right? So logicals to R are essentially 1s or 0s. True is 1, false is 0. You can pass that into here, it's totally fine. And many times when you're trying to look at missingness patterns, that's very useful. So if you said, for example, I have, these 5 columns, and I said, which ones are missing? And I got trues or falses. And then I did column means, that would give me the percent missingness in each column. If I said row sums on that, or row means, that's saying, or let's say row sums, it says how many of these variables are missing for this specific row. But if you pass in anything with characters in there, it says, I don't know what you're doing. You're probably doing something a little strange. Usually that might happen. If you look at data, you're like, it's numbers. Usually that's because there's some character data in there and you still have to do some cleaning. Okay. These also take in NA.rm equals true arguments. Summary. Summarizes stuff. It's not great. If you put it on a data set, it pretty much gives you, I don't think I show, the quantiles, the quartiles, 0, min, max, and it also does the mean for numeric data. Not super helpful. The summary command will come in handy later when we talk about models. Okay? We are going to jump past this really quickly because I want to get through a little bit of this before we go to the lab. All right. So we have some TB incidence data here. If it's in your data zip folders. So we're just going to read some of that stuff in here. And this is a data set with really weird names. Because it came from Excel, which Excel allows you to make anything your header names, and this is one example. So you will see, if you read something in read_CSV or read Excel, and they have variable names that violate some sort of rules, I will say, for how you can name your columns. So again, if you have spaces, if you have parentheses, if you have $signs, if you start with a number, it will do this strange thing with these backticks. Backtick. Backtick is the thing left on your left hand above your, or below the tilde on at least my keyboard, below the escape. It is not an apostrophe. It's a different thing. Well, never mind. You're in Stata. Backtick, right tick people. You know that. So backticks. Okay, so it said, hey, I didn't want to rename anything. I read it from Excel straight for you, so I'll keep these things. So you see, 1990 is with this little backtick because it starts with a number, not too happy. This is one of the examples of the data sets that I was talking about before, that row names would make sense because everything else is numeric but this specific column. But we're going to reformat this data, we're going to change column names, do all that fun stuff later. So, we want to do renaming. Again, we can use the rename command. That is totally fine. But in order to do that, we say rename TB dataset country equals this really, really long thing. So we just copy and pasted that column and said that and put that in there. So it says now the first column name is country. It's not this really, really long heinous thing. But in order to do that, we either had to put this in quotes or we had to use the backticks. Okay? So if it has a weird column name and you want to use that column name, you either have to use the backticks or the quotes when you're using Dplyr functions. All right, now column names, we see incidents from 1990 to 2007 in the first column is country. So again, the column means, row means, all that fun stuff. So here, we're selecting from this data set anything that starts with a 1. So 1990 to 1999, right? Any column that starts with a 1, that's just 1990 to 1999. And now we can use col means on that data because remember, every single column is numeric. And now we have the means over all the countries for the TB incidents for data that's there. Okay? Does that make sense? So we selected those 1990 to 1999. Column means took the column means of all that data. NA.rm said, if you had any missing data, I don't want to hear it. I don't want to use that. So all these numbers are based on a different set of countries depending on messages. Okay? So let's say like the US didn't put in their data for 1992. They wouldn't be in this calculation. But if they did it for 93 and 94, they would be. Similarly, let's say we want to take 1990 to 1999, and we wanted a number for every single country. Take all those numbers and create an average of those 10 numbers. That, if we took the row means of this subset, now we have one observation per row, rather than one observation per column, and then we can assign that back to this data set as something like before 2000 average. Right, so that column now represents the average of 1990 to 1996, right? Those 10 numbers added up, divided by 10. So this is, or actually divided by the number of non-missing values, right? So like, let's say the US had 5 values here, it would add the 5, divide by 5. It doesn't divide everything by 10. It will do the correct denominator. So this is egen row means, I believe, is the equivalent. I haven't used Stata in a long time, so I'm really stretching. Something I remember. Okay, so for example, so we have a different value for each one. Summary, this is what it gives out. You know, I don't know what you're supposed to see here. The only thing that's kind of relevant is NAs. I don't know. I didn't make this, right? Maybe you can see if it's symmetric. I don't know. To give you a gist of the data, right? I don't think also like describe in Stata is particularly useful, but people use that a lot. So maybe, and I feel like a lot of people use that for the NAs, for the missing. So it kind of gives a general look as described. I don't know. All right, let's hop on over to the lab so we can do some fun stuff with data. But for the most part, if you want to do things on individual columns, you can use the $sign operator to grab that vector and then run means, medians, standard deviations, all that kind of stuff. So let's go to the data summarization lab, and don't forget to load in whatever packages you need.
So we're just doing part 1 for now. And does your copy have all these 3 lines in it? Up on the website or no? I can double check. Not the 3rd line? Sorry, let me go to the website. So let's go. Data summarization. Let me just double check. All right. Just refresh if you want to grab that one. I mean, or just copy that one line. It's just the line to read in the data. That's just the standard read underscore CSV that we've been using over and over again. Yes. And that key I just had for the subsetting data is now should be on the website. It should match the lab we just did.
So how many bike lanes do you have? 1631. How do we get that in code? And row? Yep. Again, we could try dim. It's totally fine. Good. How many feet? Who's got an answer? Who's got something?
139,000.
Over 439,000. So how'd you get that?
Oh, I stored the length. Oh, I did a sum of the length. Like dollar sign length.
Yep. All right. What about that in miles? So
That divided by 5,280.
we can do it that. You could also do it inside. Doesn't matter. All right, where it either sums it up then divides by, or divides by then sums it up. It's the mean number of feet, mean length. Just using the mean, right? 269. All right. So pretty straightforward, right? Using dollar signs to access the length column, using straight up division, right? Using sums and means. We don't have any missing data in there. If we had any missing data in any one of those rows, those numbers would come out NA. You'd have to use NA.rm to remove them. I will say, though, because I've obviously seen this data many, many times, if we look at some of the bikes, and we look at length, there's some weird stuff. What is the minimum? Tell me the minimum bike length. 0. So, I didn't tell you to do any cleaning, but again, just reiterating, always look at your data. It's a pretty short bike ride. You get on, you get off. It's one. Maybe it's just one of the new bike shares. That's a lane. I wouldn't be that surprised if the city counted that. Yeah. Okay. So there's always fun stuff. All right. So we're gonna talk about some functions. So again, we're not gonna go too deep into these. They're called apply functions. They take in an array, including a matrix, but usually a data frame, and you can do things over rows or columns. So the syntax is apply, data set, margin, function. Margin, if it's 1, the number 1, means I want to do something over rows. If it's the number 2, I want to do something over columns. This sometimes can be very useful. Always goes row, column, column. So if you think of the way subsetting works, row is the first indicator, column is the second indicator. That's what margin means. 1 or 2. Usually. We're going to show how to do some things in Dplyr, but these functions are still very useful because sometimes not everything fits in the Dplyr framework, at least, or at least the way I think. So sometimes this is useful. So for example, when we were doing things before, where it was row means, column means, that kind of stuff, apply this data set. 2 means I want to go over columns. What function do I want to take is the mean. Then you pass in other arguments to this function. NA.rm, just make sure you remove that. And it gives us the column means. If we wanted column standard deviations, same thing, just to change out the function. SD. If you wanted the max, same thing, just change out the function. There are other apply statements. Tapply that allows you to do groups. You do things over specific groups. We're going to show you how to do that with Dplyr. Lapply and sapply, things that you want to go over lists. We'll do that tomorrow, I believe. There's a brief introduction here, but some of this stuff has been more or less supplanted by some of the things we're talking about in Dplyr. So we're going back to the Youth Tobacco Survey. Sorry, didn't call it YTS. This time we call it Smoke. So just a different name for the data set. Just what we felt like calling it that day. So another function that's helpful, unique, returns the unique values back in the order in which they were observed. So they don't sort them in any way. So if you want to say, what are the IDs in this data set? You say unique ID. Whatever one came first, whatever one came second, it's all, that'll be the order. You can use sort, function sort to sort them if you'd like. But in this case, we're taking the location descriptions from the Youth Tobacco Survey, and we're saying unique, meaning unique values, and here we just want to print the first 10. This data set is a nationwide survey, so not surprisingly, these are the states, but not all of the records are states. Some of them are national summaries from the data set we have. So it's just like, what things are in here? You know, what values are in here? If we do take unique and coupled with length, we can say how many unique IDs there are, how many unique records there are in this specific thing. So I think Hawaii and Alaska, or something, some of the states don't, you know, or aren't in this data set, and we have a national and some other summary measure. That's why we get to 50. It's not just all 50 states. But we do have 50 unique location descriptions. So we want to say how many IDs are in this data set, even if you have repeated measures, length, unique on the ID vector, they're all good. Table. So there's a table command in this data, there's a tabulate command in this data. Pretty much you use table in R. Right? So you table them, and it'll give you a frequency table. You can pass in one vector, which we're going to do right here. Later we're going to pass in two vectors if you want to do a crosstab or a two-dimensional table. Okay, so this, again, we're just printing out the first 5 of them. So it's saying 378 cases in Alabama, 240, 210, 96. This data is a little bit different, but it's just saying I have 96 rows that were the location descriptions California. Okay? Table, unique. So new additions. We're going to jump back to that in a minute. Yeah, why don't we do that now? That's fine. So we go back to the lab. More about bikes. How many types of bike lanes you got out there?
So we got an 8.
7.
We got 7. Who says 7? Who says 8? 7. Who says 8? 7 and an NA. Good answer. So, this is to illustrate what table does by default. So if you do unique bike type, you see the unique ones with an NA. If you say table on it, counts them up. You don't see an A. Let's see why. And let's say, and looking at this, which one has the most? Bike lane. So, you can show it in the notes, but sort, I've said it out loud many times, you can do that on a vector or a table. And you see the very last one, it's sorted. It sorts the frequencies. So we see bike lane's the last one. All right, so let's see what happened with table. What went on? So, use NA. 3 options. It's not NA.rm. It's a different argument. I wish they had kind of maybe made it the same, but there's reasons why they didn't. So if you've ever seen an argument in a function that usually have multiple choices, by default we'll take the first one. So use NA, no. So when you're doing a table, if there's missing data, saying you don't want it. Kind of like Stata, right? Tabulate, doesn't use it. You'd say miss, I believe. Yeah. Or you label it yourself, right? But if it's a dot, not in there. So let's change it. So if we use if any, it'll put a column for NAs if there are any. It'll always have a column for NAs, even if it's missing completely. Okay, and we're gonna get to the table later. Table's really nice, especially when you start making factors, because sometimes you really want a row for a table, even if that level never showed up. Right? Let's say you had a survey and you had six choices, and no one chose choice 6, but it's okay. You still wanted to report a frequency of 0. It will still do that if you make the factor correctly. All right, so let's say table, bike type. Let's say use NA. Let's say if any. So now we see different table, NA equals 9. So there's 9 cases of missing type. So how many different projects do the bike lanes fall into? So we're using the project column, right? So we can use table, right? But I didn't say to use table in there because there's a lot. We don't want to see that. So let's say unique, right? Tell us the unique ones. Again, I can just look here. It says 13. But I want to be able to do that in code, so we want to say length. So there are 13 unique bike projects. Whether we want to group them together. And again, if we're using unique, what do we see? Some of them are missing. So we're counting that. We're counting that as a level, as a project. Maybe we want to do that, maybe we don't. Right? So again, we'll show you how to remove missingness and that kind of stuff later, but just be aware of what's happening with NAs, with table and unique. All right. So we're going to take probably 10 more minutes, wrap up. So okay, now we got this data set. I'm just going to parse some of it down. I'm going to filter some of the rows, because all of it's like, if you look at the data, it's a whole bunch of stuff, right? So it's a survey repeated many times, it's estimates for men, or actually for girls or boys, and then also the aggregate data. We're going to just like filter. It's a really long data set, so I'm just going to do something like the gender, overall gender, for current smokers and their smoking status, right? That's the data I want to subset. So again, filter 3 things. I'm using equal signs to subset that kind of stuff. And I only want 3 values. I want the year, the location, and the value, the data value. Still, we have repeated measures here. I don't exactly know why we're using it, just as an example.
We should have kept some other column as a unique key. So group by, very, very important function. Because almost 9 times out of 10, every data set, you're not just taking the mean age. You're taking the mean over treatments, over groups. Right? So group by is the way you do that. It groups a data set. Right? We'll use the data, we'll group it, we're grouping this subset by the year. Right? So now the data is grouped by year. And now we want to summarize the data. So now we're introducing 2 separate functions. Group by doesn't do anything to the data, even if you reassign it, other than give it a group label. Give it an attribute that this data is grouped by this. That's all. Summarize will take that and summarize the data in any way you want. In this case, we want to take the year average, right? So we want to take the mean of data value. So again, back here. So year, data value. So for everything that's 2015, it's going to take them all together, take all these values, crunch it down to 1, regardless of what state it's in. That's what we get out here. So the syntax is group by data set. What do you want to group it by? It can be a whole bunch of variables. Doesn't matter. We pass that in summarize. We'll show you how to pipe it in a minute. This is the new variable that we want to come out in our summarized data set. Mean equals the mean value, na.rm equals true because there's missing data potentially in there. We're going to remove that. This is similar to collapse in this data. Okay, this is the way you do it with piping. Data set piped in, group it by year, summarize, year average is the mean of the data value. Same exact thing out. I'm just showing its first 6 values. So now you can do a whole bunch of stuff with this, right? And summarize like all the other functions. We could have done year average, comma. If we had 10 different variables, we could do whatever other average. We could do a column for mean, a column for median, a column for standard deviation, so on and so forth. Okay? So summarize. Summarizes the data. Usually collapses it down. Group by assigns a grouping to the data. Okay?
Can you go back to the first slide?
Yep.
So I think here you didn't generate a new data frame, but in the next one you did.
Nope. Yeah, I did. Smoke averages. Yeah, you're right. I just didn't. I just didn't reassign it. This is just going to print it out again. Didn't do anything to the data. There is some stuff we will talk about with grouping that you can't. You have to do something. You have to ungroup a data set if you want to delete one of the columns that you have grouped by. So let's say you're like, oh, I grouped over patient and then I did some averages or something. Now I want to delete the patient ID or something. If you wanted to do that, you can't unless you ungroup the data set. Dplyr, like if you say select, subtract, patient ID, it'll say, no, you can't do that. You said it group by that. So you have to ungroup it first if you want to do that. You can regroup it later. Other fun functions that summarize can play with. N is a function in Dplyr, and it does counting. So when we say group by year, n equals, again, sorry about that, that's bad. So number of observations, let's say, equals n parentheses. This is a function. This is what you get. So it counts. That's essentially a frequency table. But sometimes you want to do a column where you get n's, a column where you get means, that kind of stuff, rather than just doing your frequency table with table. This allows you to do a much more versatile thing. Tally is a function that's just shorthand for exactly that. Tally, if you group it and run tally, you'll get this exact same thing. The nice thing though, summarize allows you to do other things at the same time. But sometimes you just want to get a gist of like how many records do they have for each year? Tally is just a shorthand for that. All right, let's jump to that. Do some summarization. And then we're going to call it a day. And then maybe take 5 minutes to hear what we haven't learned and what you want to learn. Alright, so let's go over the first two. Alright, who's a vote for which bike lane type has the longest average bike lane length? What's your vote?
Side path.
Bike path.
Side path.
Side path. Okay? Everybody agreed on that? So how'd you do it?
Summarize group by.
So I have bike. What am I doing? I have bike data set. What am I?
Right.
Are you piping?
Oh, I didn't use typing.
Okay, no piping, then what are we doing?
Okay, so I use summarize, and then group by type, average or AVG equals mean length, and ARM.
Okay. In this case, there are no missing, but it's a good thing to do. All right. By the way, there is a summarize with a Z and an S. Hadley Wickham is from New Zealand. He spells them both ways. When we get to ggplot2, sometimes I will, I've just been using them for so long, I sometimes use this S for some reason. Also, color and color with a U are implemented in there. So sometimes if you see me writing in some of those, that's why.
Are they different?
Nope.
Okay.
Same exact function. The one with the Z just breaks. No. Yeah, so side path. Everyone agreed? With piping. Group by type. So note that if you do the multi-line piping, the pipe has to come at the end. You can't pipe in. You can't start with the pipe. And I'll say why that is in a minute. And I'll use the S. Average, you mean like. And that is because if I do this, versus putting the pipe at the end, and I run these two commands, that is totally sufficient. That is a complete command to R. Okay? That is completed. So it's like, all right, stop. Great, run. But when you put the pipe at the end, it says, nope, there's more. It continues. Keep reading on. Okay? So, again, you get that here. Going to do the same thing, but we're just going to change out project. Oh, my screen's a little too big. What do we got? Looks like maintenance is pretty big. Maintenance, very large length. Yeah.
How could you sort it if you wanted to do that?
What's the command we use to sort data frames?
Sort? No, I tried sort before.
How do we reorder the rows of a data frame? Arrange. Arrange. And we want to go by average. Let's say descending. Now, didn't show you this just yet. So bike date installed. Right? We showed you this in some capacity, but not explicitly. So again, $, bike date installed, bracket, right? Those that are equal to 0, we set to be NA. Tomorrow, we will show you a simpler way. Mutate bike date installed. I'm going to pipe it in there. Date installed equals if else date installed equals 0. I'm going to pull this on the next line. If else NA date installed. Pull this on the next line so you can read it all together. So we'll talk about tomorrow if else. So if else we'll do an if you'll pass in a logical indicator, and when it's true, it'll be the first thing you put in there. If it's false, it'll be the second thing. So what this is saying is if this is true, where data installed equals 0, replace it with NA, otherwise just keep it as is. So these are two different ways. This is the base way. This is the way we're going to show you tomorrow. So all date installed that are 0 is replaced. You could have done it either way. Actually, no, you couldn't have done it either way. You had to do it this way because that's the only one we showed you so far. The top one. Now we can say, what's the average bike lane length per year? They were installed. We're going to take the exact same thing. After we so again, this reassigns to that column, right? The $ and equals it reassigns it, and then what are we doing? Year. Oh, it's date installed, isn't it? Okay. 2006. It's a big year for bikes. I don't know. Alrighty. So pretty much at this point in a week, I usually try to make the analogy, right? You're learning a new language. So I don't speak any of the Romance languages. I would say 2 days in, I wouldn't expect to be completely fluent, but I would at least know some of the words and at least some gist if someone was saying some of those words to me. So R is a language. It's got syntax. It's got a whole different things. I will not make the analogy. I like to make the analogy of it's learning English. Although English is my first language, I use English because English has way too many exceptions to rules. Just like R, right? So, and there's a lot of different ways to do the same thing, a lot of different ways to say the same thing, and they can have different connotations a little bit. Some can be easier to understand than others, but it has a lot of structure, but it still doesn't have sometimes the regimented structure that you may really want. Dplyr and some of these other packages really try to harmonize some of these things to a more intuitive way. But yeah, so at least at this point, you should be able to read some data in. Step 1. Right? You should be able to do, at least with what we've done today, a little bit of grouping, a little bit of summarization. You should be able to get some means and standard deviations out. Bare minimum, right? I mean, we're not talking about making data, dance yet, but we're getting there, right? So we should be able to, subsetting and carving your data out and slicing it up is a super powerful tool. Just doing that.
One thing I would add to this would be how to apply the weight to the data. Since if it's too fast, then yeah.
That's a good question. So, survey data is not my expertise. There is a survey package. Weighted.mean is some of the things you're probably looking for. That being said, weighted.mean is specific, right? So the survey package is a lot better ways to kind of deal with population sampling weights and that kind of stuff. And population proportions, and I don't, on the top of my head, know if there's a weighted SD. So this is useful in the account just to get the mean, but if you really are trying to do what you want to do, or you're trying to get weighted confidence intervals, stuff like that, that's not going to be so useful. So the survey package, I believe, is really the way to go. I have not used it. I would have to ask some of the people in our department that really use some of that stuff. So I think Scott has done a lot of the stuff, with these.
Hadley Wickham did write a package. I don't know what it was off the top of my head. We started to use it and then ended up writing other stuff. But I have a book you can borrow that has that, like that talks about that, describes that package. That's certain.
I'm not legit, just to it's somewhere else.
Yeah.
No, that's a good point. So most of the data I usually have aren't weighted. So, and usually we never had we haven't done this to a specific subgroup before, so we haven't necessarily tailor-made it, but that's a good point. So I think the survey package is probably the most popular. I don't know how intuitive their syntax is, and I don't know if it necessarily plays very well with Dplyr, but yeah, I'll look around and see what package you're referring to. But we haven't done the super fun stuff yet, but you can do the super fun stuff. I mean, super fun stuff is like plotting and getting results, that kind of stuff. But that's to me, usually, I mean, plotting for exploratory data analysis is a lot, but the 90% of the stuff is data cleaning, data manipulation, reshaping, more cleaning, and then more cleaning, and then asking 100 people why the data is so not clean, and then more cleaning, and then results, tables, that kind of stuff.
Yeah, I was gonna say, sort of, your question, inspired another question. So I think for just one data set and doing survey analysis, you may want to use data.
Yeah.
But what are the top, I mean, you're gonna try to cover some of those, including maybe the visualization functions of R, but what are the, the attractive features of R compared to data, given, we're all systems data users?
It's free, but that's not really a reason to necessarily, give you the example. Shiny, I really like, but that's some sort of advanced fun stuff. So if you're doing, I would say standard R, it allows you to manipulate things in a way Stata doesn't. So the ability to get a frequency table out in Stata is remarkably hard for how common that function is. Like stab and stout, right? I mean, I don't know what you use to get tables out, right? But like,
It's like you can like send it to a file as a table.
yeah, like
That's about as far.
you can use post files and that kind of stuff. But like, that seems like super 101 things you want to do in a statistical language, right? And so I would say, at least for creating tables or creating things that then you can manipulate as data itself, is one of the things I find really alluring about it. Really customizing your figures, although again, that takes time, and no matter what language.
Can you look at a lot of different data sets in Stata? You can like open.
Maybe not as flexible, definitely.
Yeah, multiple things, and Stata's come a long way, right? Before you used to have to merge the using and the master to the same thing. If you had conflicts with respect to data types, it would break everything. And that, if you tried to do appending and that kind of stuff, and things weren't jiving right, you'd have to like open one, change some stuff, save it, and then have code there. Open the next one, save it, and break there. Like that, you couldn't be doing two things kind of together. That was really a nightmare. So I will say, like, Stata 14 is not Stata 10, right? I think the answer I would have given a few years ago would have been very straightforward and like, it's clearly better. But there are some more advanced statistical methods, but that's kind of a cheap thing.
Have you ever run into problems with formatting with Stata? We have like issues with some functions can only be used with like they default to Excel, so you can put a CSV ending, but then it does funny things to your output. It's much cleaner in R. What you think you're getting is what you're getting. If you try to do anything with it downstream, we've wasted a lot of time with this one project trying to sort of force Stata to do to output things in certain ways that.
Is it because your columns are so huge that?
Well, this particular issue was like it tab out, which you think you can pick